Hi everyone, good morning. Can you hear me? Hello Akash. Hi Anuj. Am I audible? Okay. So let's start today's lecture. Sorry for the delay. So today we are going to start continuous random variable, and today is going to be our last class for probability. So today's topic will be uniform random variable in discrete, and then I will start continuous random variables. Okay, so let's see uniform random variable. So we will call it discrete uniform random variable. So basically, uniform random variable is in discrete also, is in continuous also. In continuous random variable, we are going to see few random variables, and one of them is uniform, exponential, and then we will see normal distribution. Now, this uniform random variable is common in continuous and in discrete. So we will call it for the discrete case, we will call it discrete uniform random variable. For the continuous case, we will call it continuous uniform random variable. Okay. So if you want, let me just write like this. So this is discrete uniform random variable. Currently, we are going to study discrete uniform random variable. So instead of just saying uniform random variable, let me say this is discrete uniform random variable, because uniform random variable you're again going to see in case of continuous. So at that time you should be able to relate that yes, this uniform was there in discrete also. So let's see that what does it say. A random variable x has a discrete uniform distribution if each of the n values in the range, say x1 to xn, has equal probability, which means if you are having equal probability from being selecting any of the point, then this random variable is called uniform random variable. So for example, let's suppose that if you are rolling a die and then they say that x with the upward face showing, whatever your outcome is, let's suppose this is x represents the number that is coming out to the outcome. Now first of all, tell me what is a PMF of x. PMF of x. Since x can take values which are from 1, 2, 3, 4, 5, 6, and each of the values equally probable. So I will say it is 1 by 6 probability, 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 like this, right? So if you draw the PMF, it will look like this. You will say that it is 1 by 6, 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 1 by 6. So basically, this is how the uniform distribution look like, which means you will say that if every value is equally probable, then this random variable is called uniform random variable. So in this case, this random variable will be called uniform random variable, or you can say that this distribution is uniform distribution. It is very simple, and since this has been used in practice too much, so that's why they name it a separate random variable, which is uniform random variable. Let's see this example. They are saying that find the mean and variance. So can you calculate the mean and variance? Mean will be, for this particular example, it will be 1 plus 2 plus 3 plus 4 plus 5 plus 6 by 6. I mean, I have just done 1 into 1 plus 6 plus 2 into 1 plus 6, like that, right? Plus 6 into 1 plus 6. And then you will be having this, which is 6 plus 5, 11 plus 4, 15 plus 5, 20 and 21 by 6, right? It is 21 by 6, and then I think it is 3.5. So you are having mean as 3.5, and can you calculate the variance? I think you can also calculate the variance, which will be 1 square plus 2 square plus, 1 square into 1, let me write the whole thing, 1 square into, so this is your mean, this is your mean. Let me go to the next page to calculate the variance. So your variance will look like this, where everything is in the square, because it is first of all, first you will find out the expectation of x square, and then you will find out the variance. So let me first find expectation of x square. So it will be 1, 2 squared, 6 square. So what is this number? If you just sum all of this up, what it is coming out to be? Can anyone calculate? This is 36 plus 25 plus 16 plus 9 plus 4 plus 1. This is 5 and 9, 14, and this is 30, 30 and then 25. This is 55 and 36. This is coming out to be 91. Okay. Yeah. So it is 91 by 6. So you got 91 by 6, and then you can calculate the variance, which is expectation of x square minus expectation of x whole square. So which is 91 by 6 minus expectation of x was 3.5, right? Or 21 by 6. So you can say 21 by 6 whole square, and then you can get the answer. I'm not going to calculate, you can get the answer. So you can calculate the mean and variance like this. Very easy, right? I hope that is okay to everyone. Now let's just see this. Suppose x is uniformly distributed, which means that every value is having 1 by n probability. If there are n values, then it is having every value is having 1 by n probability. Earlier there were 6 values, so every value was having 1 by 6 probability. Now let's just find out the expectation and variance in this case. So which means if every value is having 1 by n in general, earlier it was having 1 by 6, but let's suppose in general if you are having 1 by n, then what will be your expectation and variance? Let's just see. So expectation will be, I think it is easy to calculate the expectation. It is 1 into 1 by n plus 2 into 1 by n, like this, plus dot 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 n into 1 by n. So from here you can calculate. It is, I think 1 by n is common. It is 1 plus 2 till n, and then this summation is n into n plus 1 by 2, and then into 1 by n. So finally you are getting n plus 1 by 2 as expectation. What about the variance? You can calculate the variance also. Let's just first calculate expectation of x square. Expectation of x square will be 1 square plus 2 square till n square upon n. What is this quantity? If you sum till n square, then what do you get? Do anyone remember the formula? If you sum all of the squares, I think it is n into n plus 1 into 2n plus 1. Can anyone recall me quickly? If you sum till n square, then what will the answer you will be getting? Okay, Roshan is saying that n into n plus 1 into n plus 1 n plus 2 by 6. N into n plus 1 into n plus 2 by 6. Yes. So now you have this one. Now you got this one, right? And then what you can do, you can just find out the variance, which is variance of x is equal to expectation of x square minus expectation of x whole square. Okay? And then expectation of x square is this one, n into n plus 1 into n plus 2 by 6 minus expectation of x ka whole square, which means n plus 1 by 2 ka whole square minus n plus 1 by 2 whole square. Sorry, yeah, this is wrong. This is 2n plus 1. Yes, yes. This is not n into n plus 1 into 2n plus 1, I think. I think 2n plus 1 is correct. Okay. So it is 2n plus 1, yes. Okay. So now you can calculate it. Let's just see how much we are getting. This is 4 and this is 6. So let's just say that we take 12 as LCM, and then this is 2 into n into n plus 1 into 2n plus 1 minus this is 4, and then this is 3 into n plus 1 whole square. And then you can calculate it. I'm not going to do it. The answer is on the on the next page, which is coming out to be n square minus 1 by 12. So if you calculate it, it will come out to be n square minus 1 by 12. So basically, the variance is this and the expectation is this. Now, I hope you can calculate the expectation variance easily. Okay. So for the given uniform distribution, it is very easy. I mean, if they just tell you that, okay, values are from 1 to n, you can just say that, okay, values are from 1 to n, then the every value will be having the equal probability. So that's why the probability is also given to you, and then you can find out the expectation and variance. Do you want to solve one question? Let's just see if you can find out the expectation variance for this. That n will be gone. No, n is important, right? N is some number that is 1 to 10 or 1 to 20 like that. At the denominator we have n. Where is n at the denominator? It is 2. It is 12. Okay. In the previous slide, no, we do not have n in the denominator, right? Anyway, like if you just solve it, which one? Oh, this n. Okay, okay. Yeah, this is 6n. Okay. Yeah, and then you have to cancel this n and n. And then I think this n was cancelled. Okay. Okay. So if you solve this, it should be n square minus 1 by 2. Okay. Let's just solve this question. Suppose that this time, see, I just told you that values were from 1 to n, but let's suppose that this time the values are from a to b, a plus 1, a plus 2, and then till b. Then first tell me if it is following this x can take these many values. Okay, x can take these many values. If that's a uniform distribution, if this is uniform distribution, then what will be the PMF? Let's just find the PMF first. PMF, find out the PMF, find out the expectation of x, find out the variance of x. What is the PMF in this case? See, how many values are there? Can you tell me? If these are a to a plus 1, how many values are there? This is just two values basically. You subtract a minus 1 to a and then plus 1. So these are two values. If it is a to b, then how many values are there? Number of values that x can take is equal to b minus a plus 1. Why plus 1? Because if you take b as just a plus 1, then a plus 1 minus a, then it will be 1. But the total number of values are 2, so that's why we are adding plus 1. Okay, you can just check with a plus 1 that a and a plus 1. If you just do b minus a, it will give you 1, but you have to add 1. So b minus a plus 1. Now, can you write the PMF? Can you tell me probability of x equal to k, where k is basically, I mean, from a to b, anything, a plus 1 till b. Can you tell me the probability of x being k? What do you think? What should be the answer here in the PMF? Yes, so Deep is having correct answer. So since every value here is equally probable, so you will say that this is 1 upon b minus a plus 1. Okay. So these values are there, and since every value is equally probable, that's why I will be having, if see, earlier there were n values, so I was having 1 upon n, and before that also there were 6 values in the dice, in the case of dice example here, so I was having 1 upon 6. Now similarly here I have b minus a plus 1 values, so I will be having PMF as 1 upon b minus a plus 1. If you are not convinced, then you can do what? You can maybe assume that probability of x equal to k is some constant equal to c. At least this is what we call a uniform distribution, right? This is called uniform distribution. Everyone agree with this? Because if it is constant across, if it is equal or constant, okay, if it is equal or constant, like whatever you want to say, I mean, a constant means like it will be equal to every of the value, then it is uniform distribution. So the underlying principle in the uniform distribution is that probability of x being anything is just constant. Okay, the same for everyone. Now, can you calculate the value of C? I think we can do it. How? We know one thing, that summation of this whole thing, which is k equal to, maybe in this case it will range from A to B, right? This whole thing, which is probability of x equal to k. This is one. That's what we know, which means that we know that for a summation, that summation that is ranging from k equal to A to B and then C equal to 1, which means you can take this C outside and then you can say that summation of A equal to k equal to A to B, and then this is just 1 inside. If you take the C outside, it will be just 1, which means like they're adding, since there is no k term, then what will be the summation? What will the summation? If there is no k term, then they are basically adding 1 how many times? B minus A plus 1 time. See, if you are having just this summation, which is, let me write here, suppose you are having this summation, which is k equal to A to B, and then just 1, then it means you can think about it like this: k equal to A to B, and then this is k power 0. Okay, 1 into k power 0. I mean, there is no k, but anyway, like if you want, you can write like this. It means 1 into A power 0 plus 1 into A plus 1 power 0 plus 1 into A plus 2 power 0. I mean, there is no k, but I'm just writing it. Okay, so 1 into B power 0 at the end. So basically, you are adding 1. You are just adding 1 multiple times. And how many times you are adding? Like since it is from A to B, you are adding B minus A plus 1 time. So B minus A plus 1 will be the answer. So basically, you can say that this value is B minus A plus 1. Then that is why the C value will come out to be 1 upon B minus A plus 1. Okay, so that's how you calculate the PMF. For the uniform distribution, the basic underlying principle is that for any particular value, the probability of being any particular value is constant. Okay. So anyway, once you find the PMF, now can you tell me that how to find the expectation? See, you know that x can take different values, which is a plus 1, a plus 2, like that till b. Now, if I ask you that what is the probability that x being some value, maybe k or anything, okay, so you will say this probability is 1 upon b minus a plus 1. This probability is also 1 upon b minus a plus 1. Similarly, every probability is 1 upon b minus a plus 1. Now, can you find out the expectation? I think it's not tough. Let's just do it. By the way, what was the earlier expectation that we got? It was n plus 1 by 2. Can you just see that from maybe the center of mass thing? Can you just see that why it is n plus 1 by 2? See, there were n numbers. This is some probability mass that is sitting at 1. This is some probability mass that is sitting as 2. This is some probability mass that is sitting as 3. Similarly, this is some probability mass that is sitting at n. And every probability mass is equal. Since everything is equal, and just think about the center of mass thing, then the center will be in the middle, right? And the middle is n plus 1 by 2. So n plus 1 by 2. This is the middle. That is why the expectation is n plus 1 by 2. Like the intuitively, I'm trying to tell you. So this is from center of mass. Okay, this is the center of mass, because everything is equally probable. So the mass that is sitting here is same mass that is sitting here is same. So that is why it will be in the middle, right? So this n plus 1 by 2 need not to be any number, which means need not to be a number that x can take. Maybe if I just ask you the probability that x being this expectation of x, it could be 0 also. Okay, which means like if let's suppose this n is let's suppose 6, then 1, 2, 3, 4, 5, 6. Then what is the expectation that we got? 3.5. If you remember, we got the expectation 3.5. But can x take this value 3.5? No, x can never take the value 3.5. Right? So that is why the probability of this could be 0 also. But that is not important. I mean, that's okay. Okay, don't get confused that this n plus 1 by 2 has to be one of the number that x can take. No, this n plus 1 by 2 could be anything that x need not to take this number even. Okay. Similarly, here, so here we got n plus 1 by 2. Similarly, here, just by using some intuition, what do you think? Like, if I just ask you that everything is equally probable, and then this is a plus 1, till B, and everything is here equally probable. So I think it will be again in the middle. Earlier it was 1 plus n by 2. So here it is seeming to be a plus b by 2. Right? The expectation is seeming to be that you will be having a plus b by 2. Let's just see if we are getting a plus b by 2. Okay, so I was here, I think, yeah. So I was here. I need to calculate the expectation. Like my intuition says that intuitively it says that I should be getting a plus b by 2. Do you all agree that we should be getting a plus b by 2? Just by the center of mass thing, right? Intuitively I can say by the center of mass. But we have to obviously check it. So let's just do it. It will be a plus b, a plus 1 plus a plus 2 like this till b, right? Till b upon b minus a plus 1. So if you calculate this is I think AP, and yeah, how many number of terms are there in EP? Like just to rewrite this b, I can write this b as if we are ranging in case of uniform random variable, if we are ranging from 1 to n, x can take, let's suppose, values from 1 to n, then the PMF, which means probability of x being anything, okay, is 1 upon n. And the expectation that you got was 1 plus n plus 1 by 2. You know, and the variance that you got was n square minus 1 by 12. ये था ना, n square minus 1 by 12, if I remember correctly. Okay, so this is if your random variable is ranging from 1 to n. Suppose you have the uniform random variable, and that is ranging from let's suppose from a to b. In general, it can range from a to b. Then what will your PMF, which means probability of x being anything, it is 1 upon b minus a plus 1. And what is your expectation? This is coming out to be a plus b by 2, and then variance is coming out to be b minus a into b minus a plus 2 by 2, 12. I most probably I think this is correct. Okay, I do not remember the formula, but most probably it is correct. The variance, it is correct, but I will just leave it to you that just verify it. Okay, just verify it. So I hope you got it, that in case of uniform random variable, how to deal with the expectation variance. The key idea is that you should be first able to calculate the PMF, and once you get the PMF, you can calculate the expectation variance also. Okay. Now let's go to this question. What they are saying, that suppose Z be a random variable with some mean and some variance, which means a mean means expectation. So expectation of Z is given to be 0, and the variance of Z is given to be 1. Now they are saying find out the mean and variance for this random variable x. Can you tell me that what is the expectation of x that you are getting? It is 5 into expectation of Z plus 2, right? So which will be expectation of Z is given to be 0. So this is just 2. And what is the variance of x? It is 5 into variance of Z. Is it correct? Which is 5 into 1. Is this correct, or there is something wrong here? Just think about it. And even see, the wrong thing is that if you take the variance of x, then it is basically variance of this thing, and then you can separate this out. I mean, this constant does not matter in the variance, so it is basically variance of 5z. But variance of 5z is not 5 into variance of z, right? So it will be variance of 5z. It will be variance of 5z, and then it will be not 5 square. It not 5. It will be 5 square into variance of z, which means it will be 25. Variance of z is 1 because it is given to us. So given this, we were able to find out the expectation variance. Actually, these kind of things we will be needing in continuous random variable when we will study normal distribution. Okay. So I will tell you there. I mean, here I'm just teaching you just as a example, but there we will be using it. So let's just solve this. Suppose that mean is 2 and variance is 25. Okay. And then they are asking you to find out the mean and variance for the Z. Can you calculate the expectation of Z? It is expectation of x minus 2 by 5. Because this is constant, you can take this outside. And expectation of x minus 2 is expectation of x minus 2 by 5. Expectation of x is what? 2. So it is 2 minus 2 by 5, which means it is 0. It is coming out to be 0. What about the variance of Z? It is variance of x minus 2 by 25, right? And then what is this minus 2 will not matter. What is variance of x? It is 25. So 25 by 25, it is 1. So that's how you can calculate. Right. Now, if you notice, these were the two examples that I have taken. In one example, I have given you that x is a random variable and which is having some mean and some variance. So let's suppose it is having expectation of x is let's suppose 2 and variance of x is let's suppose 25. Then I ask you, let's define a new random variable based on x, which is a function of x, which is z. And I have defined something like this: z equal to, what was that definition that I have did? Okay, this is x minus 2 by 5. So I said this is x minus 2 by 5. And then from here, if you calculate the expectation and variance, so this is given to me. And now from here, if you calculate the expectation of z and the variance of z, then it is coming out to be 1 and this is coming out to be 0. See here, it is coming out to be 0. This is coming out to be 1. Sorry, expectation is coming out to be 0 and the variance is coming out to be 1. Okay. This is one of the example that we did. Now in other example, what we did, we had z as one random variable. Let me write here. So this is one of the things that we did. And another thing, we had z as a random variable. We said z is a random variable. So in this example, we said z is a random variable with expectation and variance, something like this. So expectation of z is given to be 0 and variance of z is given to be 1. I mean, this is given to me. And then they have defined a random variable x, which is 5z plus 2. So they have defined a random variable x, which is 5z plus 2. Now, from here, they said, like, find out the new expectation, which means expectation of x and then variance of x. So the expectation of x that is coming out from this example is 2 and the variance is coming out to be 25. This is 2, this is coming out to be 25. Okay, these are the two examples that we did. Everyone is good with these two examples. I mean, you have given some random variable x, details about the random variable x, and then they have defined a new random variable. They are just asking the expectation and variance for this. Similarly, they have given you some information about z, and then they have defined a new random variable x. Then they have asked something about the expectation and variance about the x. So I hope you are able to do it. Now, if you notice one thing, that these are the two random variables. X is having this expectation variance. Here also X is having this expectation variance. And Z is having this expectation variance. And here also Z is having this expectation variance. So basically, I mean, we will be using it later. Sorry. We will be using it later. But I'm just telling you in advance that basically what we are doing, that these are the two random variables, X and Z. And we are like in the normal distribution, what we will do, it is actually important for the normal distribution that we will be just changing x and z interchangeably, which means given x and given z, z is one fixed random variable which is having the expectation of z to be 0 and variance of z to be 1. And given x, which will be having some expectation, maybe some non-zero expectation of x, some non-zero, some variance of x, some non-zero. Let's suppose it is 25, this is 2. Okay, suppose these are non-zero and this is 0 and 1. This is fixed. This could be changing. This is something else. But let's suppose this is fixed. I mean, you have a random variable z, you have some random variable x. Now suppose they say that given this random variable x, can you go to the z? Can you convert that to a z? Can you give me a random variable which is having this expectation 0, expectation variance is 1? Then what you will do? Given this random variable, how you will define a new random variable z? That will give you this expectation variance. So you will say, I can define a new random variable z in terms of x like this. x minus its expectation, which is 2, upon its standard deviation, which means the square root of variance, which is 5. Okay, we will do it later, but for now I'm just telling you. See what we are doing. Given this x, so in the normal distribution, it is very common. They will give you the x, and then they will say that how to define z such that your z is fixed. Actually, this is very standard thing. This is called a standard normal variable. Okay, a standard normal distribution. I will tell you later, but we will be using something like this. Given this x, I will say that how to define a z such that this z is having 0 and 1, expectation 0 and variance as 1. So you will say just x minus, so given this x, you will say just x minus do this expectation upon the variance of z, upon the standard deviation of z, you will be getting z such that this is the story. Okay. And suppose you want to go in the reverse. Actually, we never need to go in the reverse, but suppose you want to go in the reverse, then can you define x such that your expectation, this given expectation is this, expectation is 2 and variance is 25. So you can say yes, 5z plus 2. If you define a new random variable x given this z, then you can define like this, and the new random variable x will be having expectation 2 and the variance 5, variance is 25. Is this okay to everyone? So this reverse side is actually not even important. So let me just remove it. Okay. I mean, you should be okay with the forward side, which means that this given this x, they will be asking that can you get me a z which is having this which is having 0 expectation and variance 1. Then you can define this z something like this. Okay. Now, for example, let's suppose if I say that there is a random variable x is a random variable which is having expectation of x is 3 and variance of x is, let's suppose, 36. Now, give me a new random variable z such that, okay, give me a new random variable z. Actually, z is very standard in the normal distribution, but I will tell you later, such that expectation of z is 0 and variance of z is 1. Can you give me a new random variable such that this holds? What you will do, you will define something like this. Z equal to, do you remember how to define? Z equal to x minus its mean. What does this mean? 3 upon its standard deviation, which means 6. So you can define something like this. Let's just verify whether it is correct or not. Okay, let's just verify. Verify expectation of z should be 0 and variance of z should be 1. See, expectation of z, if you take this 6 will be in the denominator, and then expectation of x minus 3, expectation of x 3, so this will come out to be 0. And if you calculate the variance of z, then this will come out to be 1. That's very easy. This is upon divided by 36, and then this will be variance of x divided by 36, which means 36 divided by 36, it will come out to be 1. Okay, so you can easily verify. That's not a big deal, but that's what we will be doing in the normal distribution. So I'm just telling in the advance, but anyway, we will be doing again in the normal distribution, where I will just give you a random variable x with some expectation, some variance, and I will say that let's just convert that to z. I will again and again saying that let's just convert that to z. And how to convert that to a z? Z means z is fixed actually in the normal distribution. Z means generally it means the expectation is 0 and the variance is 1. Okay. So I will give you some random variable and I will ask you to convert it to z. Suppose that, for example, if I just ask you, let's suppose x is a random variable with this this distribution that expectation of x is, let's suppose, 4 and the variance of x is, let's suppose, 121. Then can you convert that to a z? Which means, I mean, a random variable which is having expectation 0. Okay, convert that to a z, which means, I mean, generally it means the expectation of z is 0 and the variance of z is 1. Can you do it? Can you define a new random variable z in terms of x such that expectation and variance is like this? What you will say? This is x minus its mean. What is mean? 4 upon its variance. Is this correct? Tell me. No. Why? Because in the division, in the denominator, you have 11, which means you have the square root of variance, which means you have the standard deviation. Okay, upon standard deviation. Then this is correct. you can easily verify that, let me just write it. You can easily verify that expectation of Z is 0 and variance of Z is 1. Okay, that's not hard to verify. So basically that's what we will do in the normal distribution. Anyway, so till now we have been studying studying everything in the discrete random variable, but it is just a general example. It is not very specific to normal distribution, but not in the normal distribution we will actually be using this kind of tricks. Okay, so this is very good trick that given a random variable x, how to convert to a new random variable such that the expectation variances are like this. I mean, you can convert from Z to X also. That's not a problem. Given a random variable Z, you can convert to X also. That's not a problem. But we will not be using this direction. We don't need this direction. Actually, this Z, which is having this kind of distribution, has very special properties. So that's why given any random variable X, we will convert that to a Z in case of this normal distribution. Okay. Anyway, so we will come back to this later. So I hope this discrete random variable is fine to everyone. Now, can you recall me that what are all discrete random variables that we have studied? What was the first one, second one, third one, and fourth one? I think we have studied Bernoulli. Yes. We have studied binomial. We have studied Poisson. We have studied, last one was uniform. Okay. Now let's just see the continuous random variables. So here we just have 2, 3. One is uniform. Second one is exponential, or I mean, I do not know whether this is the same order in which I will be having the slide, but that's okay. Exponential. Another one is normal distribution. So there are 2, 3 distributions that we are going to study in the continuous also. Now, if you notice, this uniform is in discrete also, in the continuous also, but that is okay. So I will call here the discrete uniform. If you want, you can call discrete uniform. You can call the continuous uniform here. Okay. So this is the continuous random variable. Now, if I ask you, what is the difference between discrete? What is the discrete random variable and the continuous random variable? Can anyone tell me the difference? We have talked about the difference earlier. If a random variable x takes countably finite values, discrete values, no, it can take infinite values also. Yeah, you can say discrete values, something like this, countably finite values. Okay. So if the random variable is taking countably finite values, then it is a discrete random variable. For example, like we have seen some examples. Let's suppose that there is a classroom. In this classroom, there are students, right? I mean, we have seen many examples like rolling a dice and these things. But we started with this example. That let's suppose there is a classroom. In this classroom, there are a couple of students. If I'm mapping that to a grade, okay, then this G, which can have A, B, C, D. Let's suppose B. Then this G is a discrete random variable. But here X will take uncountable values. Okay, which means, I mean, here it could be infinite, here also it could be infinite, but here, if in case of discrete, if it is infinite, then it is countable. And then in case of continuous, if it is infinite, it could be uncountable. If you're not familiar about countable and uncountable, let's not worry about it. Okay, you can understand in this way, very simplistic way, that discrete means finite values, continuous means infinite values. I mean, that's not very good definition, but if you are not good with the countable and uncountable sides, then you can just understand like this, that discrete means finite and continuous means infinite. So if you're mapping every student to maybe height, then this height could be anything. Maybe let's suppose this is from ranging 120 centimeter to, let's suppose like maybe 200 centimeter or something like this. Okay, so this height could be anything. So I can have any number in between this. Okay, maybe 120.00001 is also allowed. Any number in between this is allowed. Then I will say this h, let's suppose this h is a random variable, then it is a continuous random variable. In case of continuous, it takes infinite values, actually uncountable infinite values. Okay. So let's see one definition, which is probability density function. So earlier we used to have probability mass function. We do not have probability mass function here. So here we used to have probability mass function, but here we have probability density function. Let's just see what is this probability density function. So a random variable x has a PDF fx, which means probability density function. Then we can calculate the probabilities using this, which means, see, earlier we just have the PMF. We just had the PMF, and we said, let's suppose that PMF is like this, which means probability of x being maybe, let's suppose k is, let's suppose 1/6 or something like that. Okay, let's suppose this is uniform distribution, which can take from values from x can take values from 1 to, or maybe k can take values from 1 to 6. Suppose this is a uniform distribution. Then given a PMF, do I have to do anything extra to find out the probabilities? No, right? These are the probabilities only. I mean, PMF and probability were same there. But here, PMF and, here we do have the PDF, and PDF and probabilities are not same. Which means there is some extra function which I have that was not there in the discrete, which is called PDF. This is, you can say, extra. Okay. This is extra function which says that if you want to find out the probability, then you have to integrate for this function, which means I will be having one extra function, and probabilities, if I have to find out the probability, then I have to integrate from a to b fx. Okay, which means for valid PMF, so basically it means that probability of x being 0 to a to b. Suppose let's suppose, for example, if I want to find out the probability of x being a to b, then what will I do? I will take a to b integration of fx. And what is this fx? Fx I will tell you intuitively later in just one or 2 minutes. But for now, understand that fx is one extra function. I mean, that was not there earlier, and this is an extra function which is not probability. But if you have to calculate the probability, maybe let's suppose x being between a and b, then you will say that probability of x being between a and b is integration of fx a to b. Okay. Suppose if I ask you the probability of x being less than or equal to b, then can you tell me that what I should be writing here? What I should be writing here and here? If this is like this, then you will say that this is from -infinity to b, which means the minimum value of x could be anything, -infinity, let's suppose, and then till at max it is b. Okay. Now, what does this mean? If I say that integration of -infinity to infinity fx dx, what does this mean? It means that I'm talking about the probability of x where x can rise from -infinity to infinity. Actually, this is the all possible values of x, and that is why this value is 1. This value has to be 1. That is like we can check whether the given PDF is valid or not. We will integrate that from -infinity to infinity. If we are getting 1, then we can say that yes, given PDF is valid. Okay. So like x being less than or equal to infinity, you can say something like this, and then that has to be 1. Now, if you just ask me that what is the probability of x being just a, maybe you can say from a to a. If you ask me the probability from a to a, then it will be integration of a to a fx, which is just 0. Basically, a point probability in case of continuous is 0. I will tell you intuitively why it is 0, but for now understand with the formula. Okay, so we now have a new function which is called probability density function, which is basically not a probability. It is something else. It is not a probability. But if you have to calculate the probability, then we can do it at least. Okay. So why it is coming like this? 1 second. Okay. So now let's just understand this probability density function intuitively. Like, what does this mean? If this is not the probability, then what is this basically, right? Let's just see what is fx, which is called probability density function, which is called probability density function. Okay, what is fx? Let's just try to understand this intuitively. Suppose your fx look like this. It is always a continuous function. Suppose your fx looks like this. I mean, for example, I say that your fx looks like this. Okay. Suppose this is the PDF. I mean, this is some fx. Let me draw some nice graph, maybe. Suppose your fx is looking like this. Okay. Now, tell me, can the maximum value of fx be greater than 1? Answer is yes. It could be anything. Maybe let's suppose this is 10. Since this is not a probability, this is something else. It could be anything actually. Okay. So the maximum value of this fx could be anything. I mean, maximum value of the probability is 1, that I agree. But maximum value of fx could be anything. Can the maximum value of PMF be greater than 1? Can the maximum value of PMF be greater than 1? No. Because PMF is same as the probability. PMF is and the probability are same. But here the PDF and probability are not same. Can the maximum value of the PDF could be greater than 1? Then answer is yes. But the PMF maximum value cannot be greater than 1. Okay. PMF and probabilities are actually same, but PDF and probabilities are not same. But then if this is not the probability, then what is this? Let's just see. Suppose that that you are having this PDF, then tell me how to calculate the probabilities. Let's suppose this is the point 3, this is the point maybe 6. How to calculate the probability of x being between 3 and 6? You will say that you need to calculate this. Then you will say this is nothing but integration of fx from 3 to 6. Right? If you just recall, that integration is analogous to the area, which means you are saying the probability being this 3 to 6 is basically this area. Right? This area cannot be greater than 1. Okay, this can be 10, but this area cannot be greater than 1. If you calculate this area, it will be always less than 1 if it is a valid PDF. Okay. So if you want to calculate the probabilities between 3 and 6, you will take the integration and then you will calculate the probability, right? ठीक है, इतना समझ में आ गया कि if you want to calculate the probability, then you can do it, but fx is not the probability. ठीक है? Then what is this fx? Fx is basically telling us that how much likely that you are going to get a number between 3 and 6, which means that if I just say maybe let's suppose this is 9. Let's suppose this is 9. See, this interval is 3, I mean length of 3, and this interval is also length of 3. I mean, this interval is also length of 3. What if I just ask you, what is greater? Probability of x being x between 3 to 6 is greater or 6 to 9 is greater? What do you think? From this given plot, given this PDF, what do you think? Probability of x being between 3 to 6 is greater, or probability of x being 6 to 9 is greater? 3 to 6, right? So now you have your answer. Then what does this fx tell you? Fx does not tell you the probability directly, but it can tell comparatively. It can compare the probabilities basically, right? I mean, you can say that okay, most likely your x will be in this range because the PDF is higher, right? So PDF does not give you the probabilities. There is something called likelihood. It tells you the likelihood that your x will be in this range. It is having the higher probability that your x is in this range, and the lesser probability, comparatively the lesser probability that your x is in this range. That's all. It can comparatively tell you that okay, it cannot tell you the absolute value, but given the PDF, given the plot, it can comparatively tell you that okay, where is your x going to lie? Maybe in between 3 to 6, or maybe in between some other range. Then you will say between 3 to 6, which means like if I sample from this distribution, okay, like what do I mean by sample? Which means if I just follow this distribution and if I just write down some samples, then you will say, let's suppose if I follow this distribution, if I draw the samples from this distribution, draw samples, then you will say that this x that you are going to get, then most probably, I mean, there will be many numbers here. There will be many. This will be the real, I mean, real or the continuous probability distribution. But that's okay. But you can say there are many numbers here, and there are less numbers in between 6 to 9. Basically, the probability that you will get a number between 6 to 9 is actually lesser. I mean, for example, let's suppose that maybe like I don't know whether this will be a good example, but let's suppose that there is a dart you know the dart, I mean that is having some areas maybe, okay. Some areas maybe, let's suppose this is, I don't remember the plot, I mean how does it look like, but there are some areas, I think this is 100 200 like this. One second. So if I suppose, if I throw a dart on this board, then what is the probability that it will be in the some particular area? It will depend on the area basically. Okay. I mean, it will depend that if this is having the higher area, then probably that my dart will be in this area is basically higher. Now, similarly, so it is actually an example of 2D, but let me say take the example of 1D only. Let's suppose that you are having a 1D example where there are numbers which the numbers can be from 0 to 10. But you are saying that there is most likely, if you pick some number, then most likely it is from 3 to 6. Okay, it will be in this range, 3 to 6. I mean, if you draw the samples from this distribution, then your numbers will most likely from 3 to 6. Basically, from this distribution, there is a more likely that you will be getting a number between 3 to 6 compared to the 6 to 9, or maybe compared to some other range, which is, let's suppose, 0 to 3, right? So that's what this PDF tells you. I mean, this is enough for GATE, that you just need to, at max, you need to know that what does it tell you intuitively. It just tells comparatively, that it cannot tell you the absolute value of probability, but it tells the comparative value. So let me write here, PDF directly, I mean, directly cannot, I don't know how should I write it, but I mean, directly cannot tell probability, but comparatively it can tell you which range is higher. Okay, I hope that is okay to everyone. So basically, just tell you comparatively. That's all you need to know about the PDF. But it does not tell you the probability. You have to be aware of this. If someone give you the PDF, then you cannot say that this is directly the probability. Is this true? Let's suppose this is let's suppose maybe 5 or 4 or something like this. Let's suppose it is 5. Then is this true that probability of being 5 is 10? Obviously no, right? I mean, this is a PDF. F of 5 is 10, I agree, but this is not the probability, right? This is not the probability. This is not the probability. Okay. This is one idea. Another thing that we should be knowing is this. See, suppose if I ask you what is the probability of being any point, probability of x being a, which means I'm actually asking you that probability of x in between a to a, then I will say it is 0. Reason being is that the area from a to a, fx is 0. Okay, mathematically this is the reason. I will tell you the intuitive reason, but at least mathematically is this clear to everyone that probability of x being a is 0? Mathematically, right? From a to a it is 0, right? Now let's just see, if I say probability of x being probability of x in between a to b, can I write it same as probability of x is strictly lesser than a, less than or equal to b? Can I write it same as like this? Tell me. Yes, we can write. Reason being is that the probability of x being a is 0. So basically, like in fact, it is plus probability of x equal to a, but the probability of x is 0. So that's why we can write like this. Okay. So at least mathematically, this is okay to everyone. Now that is also equal to, you can say that is also equal to probability of, I mean, you can put equal anywhere, or you can just skip the equal from both the sides, or maybe you can say that equal, that is also equal to probability of maybe you can put equal at one of the side here. I mean, you can skip the equal, you can put the equal, does not matter in case of continuous case. Okay, so that is okay. Now let's just see intuitively. So it was a mathematical justification. Mathematically, you can say that this probability 0. Intuitively, actually, I mean, that's not easy to convince you, but I will try to convince you. Okay, so let's just see intuitively. Point probabilities are 0. So suppose that there is a range which is from 0 to 10. And maybe let's not worry about the exact distribution. It could be the uniform distribution. It could be some other distribution, which means maybe in between 3 to 6, there are more likely to you're getting some point or like this. That's okay. Okay. But let's not worry about the exact PDF. But if I just ask you, what is the probability of some specific point? Maybe it could be anything. Maybe 3.00127863 maybe if I just ask you this, then you will say intuitively, I'm just telling you, okay, there is no mathematics I want to do it here. I just want to tell you intuitively. Then you will say, since there are infinitely possible values in between 0 to 10, and you are just asking me only one time, I mean, you're asking me for this value. So basically, like in case of discrete, let's suppose you are rolling a die again and again. Let's suppose you roll a die 100 times. Then you will write 100 because 100 is total, right? 100 is total in case of discrete. And then if I just ask you what is the probability that you are getting 6? Then you will say, let's suppose out of 100 times, maybe, I don't know, maybe let's suppose you say that 30 times, okay? 30 times you have gotten 6. Then if 30 times you have gotten 6, you will write 30 upon 100. And that's how you are getting the probability of x being 6. Is this okay to everyone? I mean, from the sample data, like what you will do if you want to find out the probability, you will keep on doing the experiment. Let's suppose 30 times you get 6, and out of 100 times you will write something like this. Now, since the possible values are infinity here, and if I do it again and again, probably, like what do you think? I will be getting the exact same number. Maybe 2 times, 3 times at max. If I'm very much lucky, then 3 times, otherwise just 1 time. Because if next time if I roll, then it is not necessary I will be getting the same number if I just take the sample. Maybe just one digit may differ, right? I mean 639, and maybe just one digit. Maybe let's suppose this is coming out to be 3 instead of 2. One digit at least. I mean, this is very much likely that at least you are not 100% sure that every digit will be same, because it is a continuous case. There are infinitely possible values. Maybe one or two digit, maybe it may differ. Maybe in the next time, like if you do the experiment infinity times, then what is the probability that I mean, how many number of times you will be getting this number? What do you think? 2, 3, 5, and anyway, like not more than 5. Okay, I mean, you even if you do it infinity times, then in the next time maybe you will be getting maybe some 9 3. I mean, let's suppose it is 9 0, then you will be getting 9 3, or maybe some digit will change, right? So just 1 2 times, maybe 2 times, 3 times, something like this. So basically it will be a finite number here, very much finite. I'm 100% sure it will be a finite number. I'm telling you intuitively again. Okay, see, proving it mathematically is not easy. It is, I mean, like, apart from this, there is a another proof which is using a major theory and all, so which is obviously not in gate. But intuitively, if I just tell you that finite number of times you will be getting out of infinite number of times, so actually it is 0. Okay, so anyway, if you have got it, then it is okay, otherwise also it is fine. Okay, so but now you understand that what is your PDF is not a probability. It is something else than probability. But if you want to calculate the probability, then you can calculate the probability. That's the conclusion of this complete discussion. Now let's just move to our question. Let's suppose that we want to solve this question, and here they're saying x is a continuous random variable which is having the following PDF. Now, what is the value of c here? Can you calculate the value of c? See, to be a valid PMF, what it has to do? So they are saying x is greater than or equal to 0, which means that, I mean, to be a valid PMF, first of all, it has to do this, that fx should be 1. Now, since if x is less than 0, then fx is anyway 0. So let me just write it 0 to infinity. Okay, because if x is less than 0, then anyway, like fx is 0. So fx means c into e power minus x is 1. Okay. Now, can you just integrate it, and then can you calculate the value of c? What is the value of c that you are getting? See, first of all, are you okay with this? That why I'm writing from 0 to infinity? See, it should be from minus infinity to infinity. Okay, fx, and then like it should be 1. Then I said this minus infinity to infinity is same as, like I can write this minus infinity to infinity fx is same as basically minus infinity to 0 and then 0 to infinity. But this minus infinity to 0 is given out to be 0 only, right? They are saying that if x is less than 0, then this is 0. So that is why this term is 0. So that's why I'm just writing it from 0 to infinity. So I'm saying that from 0 to infinity, it should be 0. It should be 1. From 0 to infinity, fx should be 1, which is basically from 0 to infinity. Yeah, 0 to infinity, c into e power minus x, it should be 1. Then c you can take outside, and then integration of e power x is just, I think, e power x, right? If I'm not wrong. So it will be e power minus x because it is minus. So e power minus x minus, because you need to divide by minus 1 also. So it is this, and then you can say it is minus of c, minus is outside. You can say it is minus c, and then from 0 to infinity. If you put the values from 0 to infinity, which means if you put the infinity, e power minus infinity just like 1 upon e power infinity, which is 0 minus 1 upon e power 0 minus c should be 1. So this is 0, 0 minus 1 into minus c is 1, and then c is coming out to be 1. Is this correct? Just verify it quickly. Right? C is coming out to 1. So final answer is, like, if they are asking that what is the value of C, then you can say C is 1. Okay? So the value of C is 1. Now they're asking what is the probability that X being between 1 to 3, which means they're asking that what is the probability that X being between 1 to 3, then you will say it is same as the integration of 1 to 3 fx dx. And fx is e power minus x, c into e power minus x, basically e power minus x, and then it is from 1 to 3 dx. Okay, now you can calculate it. It should be e power minus of e power x from 1 to 3, and then it will be minus of e power minus 3, minus and minus will be just plus, and then e power minus 1. So anyway, this will come out to be your probability. Okay, let's not calculate the final answer because it's not required, but you should be convinced with the process, like how to calculate the probabilities in case of if the PDF is given. I mean, mostly they will ask you that much question in the continuous. They will not ask you related to the type of continuous variable. I think they have asked just 1 or 2 questions from the continuous random variable till now. If not 2, then maybe 3 questions they have asked till now, which means in the 36 year or in the 40 years, they have just asked the three questions in this continuous random variable, because it involves with the higher mathematics and integration and all. So generally they avoid to ask. Okay, but still, since it is in our syllabus, we should be looking at it. Okay, so I will tell you intuitively, mathematically, whatever is required for GATE, I will tell you all the things. Now let's just see this. Okay, C, oh yeah, C is coming out to be, to find C, we can use this property. So this is actually equal to 1, and the C is coming out to be 1. We must have C as 1, and then this is the probability of 1 to 3. Okay, these are the answers. Now let's solve this question. They're saying a probability density function on the interval a to 1 is given by 1 upon x square. Okay, which means fx, PDF they have given to be 1 upon x square if x is between a to 1. Okay, which means if x is less than or equal to a to 1, and outside this interval the values of a function is 0, otherwise the value is 0. What is the value of a? Can you do it? So I think it should be integration of a to 1 fx is, I mean, this is the only place where it is non-zero. So you just need to write the non-zero things. Okay, otherwise you do not need to write any other thing. So this is basically 1 upon x square into dx is equal to 1 to be a valid PMF, right? Now I think you can integrate it. What is the integration of 1 upon x square? Anyone quickly? I mean, if you know this is okay. Otherwise, also this is okay because I have not taken the integration class, but that's okay. It is minus 1 upon x, right? So you can say it is minus 1 upon x. A to 1 is 1, and then from here you can find out the value of a. What is the value of a you will be getting from here? It will be minus 1 upon x. A to 1 means you will write the 1 minus 1 upon 1 minus, and minus will be plus 1 upon a equal to 1. It will be 1 upon a equal to 2, and then a will be 2. Sorry, a will be 1 by 2. Right? So that's how you can calculate the ratio. So a is coming out to be 1 by 2, which is 0.5. So it was an NAT question, I think. So that's why the value of a you can write 0.5. Easy question, right? At max, they will ask these things. They will ask just 1-2 different type of things in the continuous random variable. We will see all the things, but generally they just ask these things only in the continuous random variable. You should be able to apply the integration of fx is 1. That's all. Okay. So let's just compare between discrete and continuous random variable. Then we will see the different type of continuous random variables. And the first continuous random variable will see uniform, then normal, and then exponential. So let's just see the difference between discrete and continuous random variable. So discrete random variable takes the values which are basically countable values. Let's suppose the discrete values, which are, let's suppose the 1 to infinity, like something like this. It can take any values in some range, which means it can take infinitely possible values, and that is in fact uncountable. Okay. So it can take infinitely possible values, but it will be taking discrete values here. Now here I used to have the probability mass function, but here I will be having the probability density function. Here, if you remember, then we were having CDF. Here also the name is same. See, the only difference is between PMF and PDF, but the CDF is same. Which means here earlier I used to say probability of x equal less than equal to k is a CDF, which was something like this. If you remember, there was CDF, some definition of some function, and then the same story here. You can have the similar CDF here, but it will be obviously like you need to calculate it separately using some other formula, which is minus infinity to k this fxdx. Earlier it was all the probabilities that are giving out to be your x less than equal to k. So you can calculate the CDF in both the cases. Earlier the expectation was something like this. Here the expectation will be minus infinity to infinity x fx. Okay. The formulas are changing. That's all. And earlier the variance was this. Here the variance is this. I mean, variance formula is same, but the expectation you need to calculate differently. The expectation of x square will be minus infinity to infinity x square fx. Okay. So you can look at this slide later also. I mean, you at the time of revision, that what is the difference between discrete and continuous. There is no difference apart from this PDF and PMF. And then obviously the formulas of the expectation, these things also vary, because the whole calculation of the probability is even varying. Let's just see the first distribution, the first continuous distribution, which is the uniform distribution. It says that given any range, maybe in between A to B, okay, given any range, let's suppose you are having in between A to B, you are having a non-zero PDF. Sorry, yeah, non-zero PDF. Yeah, this is PDF, which is a probability density function. It says that in between A to B, you are having non-zero, and let's suppose for every other value which is zero. Okay, for every other value which is zero. Now, if you draw the samples from this kind of distribution, that from A to B it is non-zero, every other value will be from 0, then your data points will be in between A to B only, right? I mean, since the probability of having something here is 0 itself, here is 0 itself, because the PDF is 0, then probability is 0, right? If PDF is non-zero, then probability will be obviously something. But if PDF is 0, then I can say that there is no density function here. So I will not be getting any sample from here to here. You're getting my point? If you draw the samples from this distribution, you will be getting all the points from in between A to B. Now, uniform distribution says that's okay. I mean, in between A to B, that's okay. But uniform distribution says that there's an equal probability that you will be getting something in this interval. Let's suppose this interval is having a length of 1. Then let's suppose this interval is having a length of 1. Then equal number of points will be here and here, which means these lengths, if length is 1, then the number of points in this length is same as any length 1. which means if let's suppose you are getting some number of points, maybe let's suppose 100 points here, then you will be getting 100 points here also, which means if length is same, then the number of data points are also same. It says that probability is directly proportional to length of the interval. Okay, so let's take a break and then we will continue this uniform random variable. I think we can take a break and then we will continue. So you're understanding the point that what I'm trying to say, or maybe we can take a break and then we can understand this uniform random variable, and then after this uniform we will be having normal distribution and then exponential distribution. Okay. So we will be finishing the lectures today. We will not be continuing on this probability lectures tomorrow. So I will just try to finish this probability today only. Yes. Okay. Let's meet at 9:20. Is this fine? Okay. Let's meet at 9:20. So I was saying about something about the uniform distribution. So in the uniform distribution, I say that there is a, like for the PDF, this is the equal PDF for every value. I mean, from in between this A to B, the PDF is equal, which is C. Now then I said, like for any interval, whether it is from maybe from 2 to 3 or from 6 to 7, does not matter. It depends on the length of the interval. If the length of interval is same, then the probability is also same. I will prove it in a while. So there are one or two things that we need to see, that what is the value of this C, and another thing we need to see. First thing, what is the value of C, value of this C. Another thing we need to see is this, like why I'm saying that probability is directly proportional to length of interval. Okay. So let's just do step by step. So first is like, what is the value of C? How to calculate the value of C? It is easy. So you need to basically make this PDF, which is from -infinity to infinity, fx, which is same as in this case from A to B, fx, it should be 1. And what is the fx here? From A to B, it is C. So you will say from A to B, this C dx, I mean fx dx basically, fx dx, it is 1. And then it means C into x, A to B is 1. And then from here, if we want to find out the value of C, it is coming out to be B minus A. Right? It is B minus A. I hope that is okay to everyone. Okay. Okay. Now C is coming out to B minus A. So how to calculate the C? You can just integrate this from A to B, and that is 1. Which means that this height, I mean this height is basically C, which I was interested, because this is same from A to B. This is the plot of PDF, which is same. Now this height is coming out to be 1 upon B minus A. That's okay. I mean, this is one of the way to calculate this height, but another way could be like this, since it is just a rectangle, you can say you want to calculate this height, which is C. Okay, since this is just a rectangle, and the integration means the area of the rectangle. So which means height into width. What is the height? C. What is the width? B minus A. C into B minus A should be 1, and then from here you can calculate C, which is 1 upon B minus A. Okay, I mean, in case of uniform, this calculation becomes very easy. You do not need to actually integrate. You can just deal in the rectangle. Okay, in case of uniform, because this is just a rectangle, so integration is just finding out the area, and we know the area is height into width. So in case of rectangle, the calculations, sorry, in case of uniform, the calculations are actually extremely easy. Okay, I hope everyone got this, that how to calculate the C. Now I said, like, there are two things I have stated here. One is that what is the value of C. Now I know the value of C, which is 1 upon B minus A. Okay. Now another thing I said, like the probability of any interval, like being in any interval, basically is the length of the interval only. Let's just see this. I mean, why it is true and why it is even making any sense. Suppose this is your PDF, and let's consider another PDF, which is let's suppose something like this. Now tell me, here in this PDF, let's suppose this is 3, this is 6, this is 9. In this PDF, the probability being 3 to 6 is greater, or 6 to 9 is greater. Obviously, 3 to 6 is greater. I mean, the area is greater, right? This area seems to be greater, so 3 to 6 is greater. But here, let's suppose I have 3 to 6 or some interval here. This is 3 to 6. Here, maybe 6 to 9. Here, tell me 3 to 6 is greater or 6 to 9 is greater? Same, right? What about 3 to 6 and 6 to 10? Let's suppose this is 6 to 10. Which one is greater? 3 to 6 or 6 to 9? This 3 to 6 is greater or 6 to 10 is greater? This one. Is this same? No, it cannot be same. How it could be same? 6 to 10 should be greater, right? I mean, you just calculate the area. Here, this is 3 into, what is the area here? This is 3 into C. I mean, this area is 3C. This area is 4C. So obviously, this 4C is greater, right? So this 4C is greater, like there is no doubt in this. So basically, it depends on the length only. I mean, if the length is 3, then it is 3C. It could be anywhere, okay? If length is 3C, if length is 3, then this 3 length could be anywhere. Let me go to the next page. Suppose this is the PDF you have, and then if I ask you what is the probability being in any interval, let's suppose 3 to 6 or any interval, then you will say, let's suppose this is 3, this is 6. The probability that X being in between 3 to 6, then you will say this is 3C. Because it is basically the area of this, which is 3 into C. I mean, if you want, I can calculate it mathematically also. Let's suppose this is 3 to 6 and fx dx. That's what we want to find out, right? And what is this? Can anyone calculate this? This fx is, I think, C, which is 1 upon b minus a. So this is 1 upon b minus a dx from 3 to 6. I mean, let's just calculate, let's just take it as C, okay? I mean, I can put the value of C, which is 1 upon b minus a, but let's just take it as C. So it will be Cx, and then it is basically 3 to 6. If you calculate it, it will be 3C only. I mean, actually, I do not want to use the integration in case of uniform, because if life is simple, then why to make it complicated? Do you want to use integration, or you just want to use height into width? Obviously, height into width, right? I mean, why to use integration if you have the directly height into width? So whenever you want to find any probability in case of uniform, just apply height into width. Okay, don't do integration. I mean, you can do integration. That's not a problem. But height into width is actually very easy to do it. So one thing is that if I just ask you that what is the probability in between 3 to 6, you will say this is the probability. Now, other thing is that if I ask you what is the probability in between 6 to 9, then you will say in between 6 to 9, since this width is 3, height is C only, so you will say the probability of being 6 to 9 is 3C only, right? 3C. Now tell me, what is the probability in between 6 to 10? 6 to 10. You will say it is 4C actually, right? It is because the height of the width is 4, so that's why it is 4C. So basically, it depends on the length of the interval. If the length of the interval is 3, does not matter. Where is this 3? Is this 3 is here, this 3 is here, does not matter. Right? So the probability of that interval, probability of any interval, is basically probability of any interval, you can say, is length of the interval into C. Basically, you can say it is directly proportional to length of interval. Okay. It is directly proportional to length of interval. So probability of any interval is directly proportional to length of interval. That's why I have written there that probability of any probability of any interval. Basically, I should be writing here probability of any interval is directly proportional to the length of the interval. Yes, height is constant. Yes, that's nice observation that height is constant. Height is same for everyone. Okay. ठीक है, ये आ गया सबको समझ? Now, let's just calculate the probability in between C to D. Can you do it? Do you want to use integration, or you just want to use the normal thing? I think the normal rectangle thing should be okay. Height is 1 upon b minus a, and length is d minus c. So it is d minus c into 1 upon b minus a. So it is d minus c upon b minus a. It will not be plus 1. Actually, here this the point probabilities doesn't matter. It will not be plus 1 and minus 1. Okay, so the point probabilities doesn't matter. This d is not having any significance in its own. I mean, d, and then this the next point will be just lesser than d. So the point probabilities here are 0. Okay, so length of the interval and the number of points in the interval are actually different thing. If I just ask you what is this length of the interval, then you will say the length is just 1. The length of this interval is just 1. Similarly, if I ask you length of this interval is 2, right? And if I ask you the number of points in between 1 to 3, including the 1 to 3, then these are 3, right? Number of points in the interval, including 1 to 3, is 3, but the length of the interval is just 2. Anyway, I hope it is fine to everyone. So it is d minus c only. It will not be plus 1 because the length of the interval is different and the number of points are different. Okay, we are not calculating the number of points here. We are calculating just the length. Okay. So here also you can see the length is it like the probability of this interval depends on the length of this interval. If the length of this interval d minus c, then it depends on d minus c. Okay, it does not matter where the c and d are located, which means if this is 3, this is 6, then this will be 3. If c is 3 and maybe this is 7, d is 7, then this will be 4, something like that. So I hope you are convinced that the length, the probability is basically the directly proportional to the length of the interval. So that's why it is uniform, which means if for any interval given the length is same, it is uniform. Okay, so that's why we call it uniform. For any interval, the probability is same. I mean, if the length is same, obviously, right? If I'm being fair to them, which means if I'm having the same interval, the same the length of the interval, then the probability will also be same. Okay, the probability is coming out to be this. Okay. Now let's just calculate or let's just solve this question. So here they have this. Let me erase this. So they are saying that x is a uniformly randomly distributed over 0, 10, which means that from 0 to 10, it is uniform distribution. Now, do they have to tell you? Do they have to tell you the PDF? If they are saying that that is from 0 to 10, can you calculate the PDF? Can you tell me from 0 to 10 if x is from 0 to 10? Or like open interval, closed interval does not matter in case of continuous. Okay, like the continuous the point probabilities are 0 basically. So can you like this is 0 basically, can you calculate this quantity? This will be if it is c, then actually this is 1 upon b minus c, right? I mean, if you want you can calculate it. This is 0 to 10, this is c, and then the area is 1, so thus 10 into c equal to 1. So basically it is just 1 upon 9. Okay, 1 upon 9. This is 1 upon 10. I mean, you can calculate using the area. I mean, if you want, you can use the integration, but let's avoid the integration altogether. Now they're saying that what is the probability that x is less than 3? What is the probability that x is greater than 6? What is the probability that like this? So can you calculate these three? X is less than 3. X less than 3, which means you are talking about this. So let's just do using just a rectangle thing without using the integration. So length is 3 by 10, right? It is very simple, 3 by 10. I mean, length is here 3. It is just length divided by length into this c. And what is this probability x greater than 6? Can anyone tell me very quickly? What is the length? X greater than 6. They're interested in this. Length is 4, right? So 4 by 10. I mean, if length is 4 by 10, it is very, very easy. What is the probability that this is between 3 to 8? What do you think? What is the length? Length is 5, so 5 by 10, right? Very, very easy. I mean, uniform is actually very easy. Okay. I mean, if you want, you can use the integration. Like here, just for the sake of mathematical notation, they have used the integration, but I will prefer like you use the rectangle thing directly. Okay. Integration is also fine. Rectangle is also fine. Okay. Let's just see this. Now they are saying that for the uniform probability density function described earlier, a equal to 0 and b equal to 10, fx is this. Okay, that they have just given it, but otherwise we could have calculated it, right? This is 1 upon b minus a. We could have calculated, but that's okay. They are saying find the probability this. Can you tell me quickly what is the probability this? Tell me very quickly. 15 minus 1, which is 14 by 20, right? 14 by 20. And what is this expectation? Yeah, expectation we have not calculated till now for any continuous random variable. Let's just do it for the very first time. Expectation formula will remain same, which is minus infinity to infinity x fx dx. Okay. Earlier it was summation. Now it is integration in expectation of x, which is basically same as here. The probabilities are non-zero. This PDF is non-zero in between 0 to 20, right? 0 to 20. X fx is 14 by 20 dx. Okay, so if you calculate, it is x square by 2, and then this is 20 square by 2. Let me write first. This is x square by 2. So this is 14 by 20 into x square by 2, 0 to 20. So it will be 14 by 20 into 20 square by 2. Okay, it is 10, 140. So expectation is coming out to be 140. ये आ गया सबको समझ? Now, can you see it intuitively also? Like why this expectation is coming out to be 140? Let's just see this. See, this is from 0 to 20. You know, this is the PDF that is given to us. Okay. This is C. And C is given to be 1 upon 20. ठीक है. Sorry, this is 1 upon 20. This is not 14 upon 20. This should be 1. This fx is 1. So this is 1. This is 1. And finally, we have this 20 get cancelled out. We have just 10. Right? Okay. We have 10. Yeah, 1 upon 20 is given. We have 10. So we have 10 as answer. So basically, like, I mean, from this also you can I'm like you can figure out the expectation. Expectation is basically sitting in the middle, right? If it is uniform, then it should sit in the middle, which means this is 0, 20, then this should be 10, right? On average, like you can say the expectation is 10. Anyway, like we can calculate it mathematically. Let's just do it for the longer example, which means let's suppose that in general, your range could be from A to B. Let's suppose your range is from A to B. Then let's calculate the expectation variance. Okay. So range is from A to B this time. Then can you write the PDF? Can you write the PDF? It is 1 upon B minus A. X is in between A to B. Does not matter. This equal does not matter. You put equal, you do not put equal, does not matter. Otherwise, this. Okay. Expectation is basically expectation of X is x fx dx, and in this case it is from A to B, which is A to B 1 upon B minus A x, which is actually x square A to B, and then 1 upon B minus A. If you calculate it, it will be B square minus A square, and then it will be just, B square minus A square upon B minus A. This by 2 is remaining somewhere. This is fine. Yeah, x square by 2. X square by 2. So this is by 2. So it will be A plus B by 2. You can calculate the mean. It will come out to be A plus B by 2. Okay. This mean, generally we denote the mean by mu, but let's not worry about it. And the variance by the sigma. Okay. So sigma square basically. So mean or the expectation is A plus B by 2. And the standard deviation, or maybe you can calculate the variance first, and then we will calculate the standard deviation. So the variance, like we do not actually need to calculate because these are the integration in these things. So we will just remember it forever. So it is x square fx dx. Expectation of x square is x square fx dx from A to B, which is basically fx is 1 upon B minus A, x square dx A to B. This is x cube by 3, and then this is b cube minus a cube by 3 into b minus a into 1 upon b minus a. Then it will be what is the formula? A cube minus b cube, a minus b into something, right? So do anyone remember the formula? I think it is b minus a. Okay, there is some formula, I do not remember exactly, but till now it is fine. This is 1 upon b minus a. I think things are good, right? Okay, this is bq minus aq. So basically this will be x cube by 3 from a to b. So it should be fine, right? And then if you calculate it, it will come out to be b minus a whole square by 12. So I hope the calculations are fine. Do you see any flaw in the calculation? Yeah, seems good, right? So this is x squared. Oh, sorry. Like this is not this answer. Like first you need to calculate this, then you will be calculating the variance. The variance will be variance of x will be expectation of x square minus expectation of x whole square. Right? So expectation of x square you need to put this, and then expectation of x whole square. Then it will come out to be b minus a square by 12. So anyway, we will just remember it forever. Okay, we will not calculate the expectation variance for any random variable again and again. And for especially for the continuous, you just remember it. Okay, you should not calculate it again and again. So especially for the continuous. Now I hope that is fine. Now let's just see some question. So suppose they are saying that bus is uniformly late between 2 to 10 minutes. Okay. Now how long can you expect to wait? Which means the bus could be anywhere late. So basically x is a random variable that is a uniformly distributed between 2 to 10. Now they're asking what is the expectation of x. I mean, on average, how much you should be waiting. It is a plus b by 2, which is 2 plus 10 by 2, which is just 6, right? Yeah, mu is 6. Now the second question they are asking, how long can you expect to wait? This is the first question. With what standard deviation? Which means standard deviation basically tells you that how much it is varying. So let's just first find out the variance. Variance of x is b minus a whole square by 12, which means this is 10 minus 2, 8 square by 12. 8 square by 12. Now standard deviation, which is generally represented by sigma, which is square root of 8 square by 12, which means 8 by square root of 12, which means this is, if you just calculate it, there it is coming out to be 2.31. Okay, 2.31. Now, what does this actually tell you, standard deviation? Can anyone tell me what does this standard deviation tells us? It generally tells us that we are expected to wait on average six minutes. I mean, on average, the bus will be 6 minutes late, but most probably, I mean, it is basically the 6 minutes late, but with the standard deviation of 2.31. मतलब कि हो सकता है कि प्लस माइनस 2, मतलब हो सकता है कि like if I just consider it 2 then हो सकता है कि 4 मिनट वेट करना पड़े, हो सकता है कि 8 मिनट वेट करना पड़े. But on average, I need to wait for 6 minutes, but with the standard deviation of 2, which means that on average I need to wait for 6 minutes, but on average with the standard deviation of 2 also. 6 minutes with the standard deviation 2, which means 6 is not the average. It will fluctuate. Sometimes the average will come out to be 4, sometimes the average will come out to be 8. A standard deviation just tells us that how much you are deviating from the mean, basically. Okay. I mean, these are some graphical things that if you know it is okay, otherwise GATE will not ask it. Okay. So you will be late for the work. What is the probability of you being late? If, okay, they are saying the third question is that if it is greater than 7 minutes, then you are late. Which means it could vary from 2 to 10. It could vary from 2 to 10. The timings could vary from 2 to 10. They are saying if it is greater than 7 minutes, अगर वो 7 मिनट से ज़्यादा late हो जाती है बस, then you will be late for your work. Which means if you are going to office or if you are going to college, you will be late. Then what is the probability that you will be late? Which means what is the probability that your random variable will take this value? I mean, they are asking of this probability. Which means this length is 3 and 3 into what is this 1 upon b minus a, right? 3 upon 8. 3 upon 8 आना चाहिए ना? Why you are getting 17 by 2? Let me check the answer. 0.375. Yes, 3 upon 8 is the answer, right? I mean the length upon b minus a, basically the height and width. So b minus a is basically your height, and this is 3. 3 into this. I hope you got it. See, this is 7, let's suppose 7, and then this is your 8. So they're asking about this area, which is 3 into 8. Oh, sorry. What am I saying? This is not 8. This is 1 upon 8. Yeah, 3 into 1 by 8. They are asking about this area, which is 3 into 1 by 8. Okay. I hope this question is clear to everyone. Now let's move to another random variable, which is normal distribution or normal random variable. Sometimes we also call it Gaussian distribution. Okay. See, the distributions, if you have noticed, and you should be convinced till now that whatever we have seen till now, maybe Bernoulli, binomial, or whatever we have seen, are basically based on some general phenomena, which means that they occur too often in the practice. Like if you ask about the Bernoulli, then if you're tossing maybe if you are having n trials, then sorry, if you ask me about the binomial, not the Bernoulli. In case of binomial, if you are having n tries, then how many success you are getting? That is modeled by the binomial distribution. Similarly, uniform is also, like in case of discrete, uniform is very general phenomena, like head and tail uniform, dice rolling uniform, like that. The uniform is general phenomena. Here also uniform is general phenomena, right? So uniform is also general phenomena, and whatever we have seen is actually general phenomena. Similarly, this normal distribution is also very general phenomena. And in fact, it is extremely general. I mean, it is very, very natural phenomena, which means the PDF of normal distribution is given like this, which says that if any random variable is following this kind of PDF, then we call it a normally distributed. Okay, normally मतलब ये तो expected ही था, मतलब normal मतलब हाँ life is normal like that. Okay, मतलब बहुत काफी normal चीज है, ये इतनी normal है कि we are calling it a normal distribution. Okay, so I hope you are getting. Now let's just see that how to calculate. I mean, what does this mean for the normal distribution? Let me also tell you more. So basically, what do I mean by that? For any random variable, let's take some example. Maybe let's say that you are in a class, and then there are many students in the class. So generally what happens that most of the people lie in between. Matlab most of the people are average, right? I mean, there are some people which are below average. There are some people which are above average, but most of the people are average only, right? So this is actually very normal to have these kind of distributions in a class. If you have some test, then generally the marks of the test follow the normal distribution only. I mean, if the marks of the test are, let's suppose, from 0 to 10, then most of the people will lie in this interval. Let's suppose this is from 3 to maybe 8 or something like this. ठीक है, वो फर्क नहीं पड़ता. But most of the people marks between 3 to 8. बहुत ही कम लोग होते हैं जिनके 3 से कम होते हैं, कम लोग होते हैं जिनके 8 से ज्यादा होते हैं. So basically, it is very normal phenomena, extremely normal actually. And this is one of the most important with respect to machine learning, which means in case of practical applications, without this distribution, like machine learning applications cannot even exist. I can go to that extent, which means most of the data distribution that we use in machine learning we say that it is following a normal distribution. Okay, I mean, most of the things in a general life follows a normal distribution. You take anything. Maybe if I just take another example, let's suppose if I talk about the height of the people, then let's suppose the height of the people are varying from, let's suppose 4 foot 8 inch or something like this. Let's suppose it is maybe anything. Okay, maybe let's suppose 4 foot 8 inch and 2 maybe 6 foot 10 inch. Okay, maybe 6 foot 5 inch, something like that, right? So height of the people is also in general, like most of the people height is in this region only, right? I mean, most of the people are common. Okay, most of the data is a common. I mean, most of the mass is always together. There are few people which are having the lesser height. There are few people which are having the greater height. So that is why this normal distribution is very, very popular and very, very normal. Actually, this is so normal that we call it normal distribution. Now you can guess it, like how normal it is to get this normal distribution. And with respect to GATE, I think they have not asked any question. I think they have just asked one question, I think, till now. Actually, in the whole continuous, they have just asked 2-3 questions, I think. I'm not 100% sure, but maybe like 4 questions they have asked. So with respect to GATE, it is not important, honestly. I mean, with respect to GATE, you are just good with the 2-3 things. That minus infinity to infinity fx is just 1. You should be good with this. And another thing is, at max they can ask you about the uniform distribution. That is all. I mean, with respect to GATE, this normal and exponential distributions are not important, but in the machine learning or in general life, this is important. Okay. So, but anyway, for the sake of completion, we have to study this distribution also. Otherwise, they have not asked any question from this distribution. I think they have asked just one question. I may be wrong. Maybe there are 2 questions, but I think they have asked just one question. Okay. So anyway, this distribution is symmetric about the mean, which means like we need to calculate the mean obviously, but let's suppose I calculate the mean, I calculate the expected value, then expected value will come out to be in between only. This is the expected value. This is symmetric about the mean. Okay. And the PDF is having this formula. See, in case of uniform, what was the formula of PDF? Do you remember? It was 1 upon b minus a. Okay, in case of uniform. Here it is having some formula which is looking like this. I mean, which is 1 upon under root 2 pi sigma, or maybe something like this. Let's not worry about this formula at all. I mean, for the gate purpose, this formula is not important. So I will not ask you to remember this formula also. Okay. I mean, you do not need to remember this formula. But yeah, there is some formula of PDF. And if you plot this with respect to x and fx, this mu and sigma are just parameter. I mean, you can just treat them just some constants, maybe k1, k2, something like this, which means maybe you can say this is, let's suppose this is some constant, this is k1, this is k1, this is k2, something like this, which means if they give you k1 and k2, if they give you these two parameters, then you should be able to find out this fx. Okay. Similarly, what are the parameters in the uniform? Can anyone tell me what are the parameters in uniform distribution? Parameters means anything apart from x or k. So A and B are parameters. Okay. So we generally call it uniform bracket A comma B. So in the bracket, we generally write the parameters. I mean, that's a general notation. So A and B are the parameters means if they tell you A and B, can you plot the uniform distribution? Can you plot the PDF? Can you find the probability? Then we can do everything. If they give you A and B, so that is why A and B are the parameters. So here the parameters are K1 and K2. Okay. I mean, they will give you two numbers and then they will ask you few things. They will say based on these two numbers, let's have some normal distribution. Okay. So for the gate purpose, actually this formula is not important, but that's okay. I mean, we are just having this in the slide. Now, if you calculate the expectation using this formula, then what is the expectation? This is minus infinity to infinity x fx. Okay. If you put that fx, that complicated formula, that is basically, I do not even remember, but yeah, this is 1 upon under root 2 pi sigma into e power minus x minus mu square by 2 sigma square. Sorry. Okay. So this is fx. If you put it, then you are going to get some value, and obviously that will be in terms of this k1 and k2. I mean, the x will get eliminated. That's okay, right? I mean, you are integrating from minus infinity to infinity. You will not be having any x term. Obviously, you will be having any term which are either mu, sigma, 2, or some constant, right? So finally, like if you do it, we do not need to do it, but finally the answer is mu. Okay. Obviously, we never need to do it, but the finally answer is mu. So basically, the expectation is mu. And similarly, if you find the variance, I mean, first you find the expectation of x square, and then you find the variance, which is basically expectation of x square minus expectation of x, then it is coming out to be sigma square. Okay. I mean, this term square, whatever is this term. So anyway, they will not ask you the formula. They will not say these kind of things. They might say that, okay, expectation and variance. They might give you expectation and variance, which means they have given you K1 and K2. I mean, this K1 and K2 they have given you, right? They just need to give it K1 and K2, which means they give you K1 and K2, and they can ask you anything about this PDF or these things. I mean, in general, right? I mean, you should be able to get from this formula, you should be able to plot and everything. What are the required things here? K1 and K2. What are the required things here in case of uniform? What are the required things? A and B, right? And distribution. What are the required things in Bernoulli? What are the required things? It is N and K, right? If you ask about the Bernoulli, the formula is N and P. N and P. Not K. I mean, the K will be given, x equal to K. This is the value of x. A value of x is not needed. And then they will say p power k into 1 minus p power n minus k, something like this. These are called actually parameters. And generally people write like this: Bernoulli bracket mein parameters, uniform bracket mein parameters. Similarly, normal distribution, I mean, instead of writing whole normal, generally people write like this: normal distribution bracket mein parameters. Okay, k1, k2. Something like this. I mean, this k1 is actually just mu and k2 is just sigma. So they will write mu sigma. So basically, they will give you K1 and K2 mu sigma or something like this. Then they can ask you anything about this normal distribution. I hope that is fine. Okay. Okay. Now, instead of giving you K1 and K2, they will say the expectation variance. I mean, they will be just bit clever. They will not say that mu and sigma is this. They will say expectation variance. Then can you map, like, see, one thing is that they will say that mu is this and mu is 3 and sigma is 5. Let's suppose they say this. Then obviously you can draw all the things, you can do all the things. That is okay. But instead of saying mu and sigma, they will just say expectation and variance. Since I know that expectation is same as mu and variance is basically sigma square, so I should be able to calculate mu and sigma given the expectation and variance. Okay, so they will not say directly mu and sigma. Like they could have said it because these are actually same, but instead of saying like this, the mu is this, sigma is this, they will say expectation is this and variance is this. Okay, so you just need to calculate mu and sigma using the expectation variance. That you can easily do because this is just same. I mean this is sigma square, but that is okay. तो इतना समझ में आया, right? So basically this is very general phenomena, and how they will ask you question I will tell you, but they will not ask you question related to the formula of this fx. Okay, the formula is complicated, they will not ask you. I will tell you that how they will ask you. Before that, let's have some interpretation of this this normal distribution. Okay, so suppose let's suppose that this is the graph that I have for the normal distribution. Let me just copy this. This is the PDF, right? That's what we call PDF. Now, let's suppose that the mean here is 5 and standard deviation just tell you, I mean the standard deviation or the variance, let's suppose anything, maybe 10. Okay, then this is the plot you are getting where the variance sigma square is 10 and mean is, or maybe let's suppose the standard deviation is 10 or mean is 5. Or maybe let's suppose standard deviation is 1, maybe 2, standard deviation is 2 and mean is 5. Then let's suppose this is one of the plot I'm getting. And now if I just say that what will be the plot if I just change the values, giving this plot, if I just change the values and if I say that what will be the plot for mean 3, then you will say the plot will be exactly same. I mean, plot will be exactly same. It might shift left and right. That's all. Plot will be exactly same, which means this width and these things exactly same because you are not changing the variance. Variance is same means the data distribution is same. You are just changing the mean. So here it is 5, here it is 3. Okay. But suppose you change the variance also, which means now if they ask you that how the plot will look like if the variance is maybe, and just a second, let's suppose that they will ask you that how the plot will look like if the variance is something else. Suppose that mean is 5 and variance is, let's suppose, 4. Then the plot will be same or it will be different? Tell me. It will be different, right? Mean is 5. Here also see, just compare this diagram and this diagram. Mean is 5 both the places, but variance or the standard deviation is 2, but the standard deviation here is 4. So it means the variance is more. If the variance is more, then plot will be wider actually. Will be mean is 5, so that's okay. The plot will be something like this. If the variance is getting increased, okay, it will be different actually. Okay. So let's see for different, probably for some different values. Let's suppose the variance here is 1, then it will look like this. And mean is in these two cases, mean is 5 only, but variance, if I'm increasing variance from 1 to 4, then it will be wider. Okay, because the variance, the data is varying much now. See, if you have the data, then data is concentrated here. I mean, for this plot, the data is concentrated here. But if you are having higher variance, then data will not be that much concentrated. The data will be in this range. Okay, and here the variance is 1 and the mean is 15, which means the variance is same as this. So the plot will not change; it will just shift. Anyway, this kind of graphical understanding, I just wanted to make sure that you get it. Otherwise, that's fine. I mean, you should be able to have some picture in your mind if you are understanding this particular random variable, because it's all about the how you can visualize this plot in your mind. Okay. Now, for the normal distribution, it is always symmetric. मतलब ऐसा नहीं है कि I give you any bell curve. This is called bell curve actually. Okay, these kind of curves are called bell curve. So suppose if I give you any bell curve, maybe something like this. Is this a normal distribution? No. Okay. Normal distributions are like this only, like this only. It may change from the variance and may change from the mean, which means it is symmetric on the mean and these kind of things. It is not like any bell curve, anything is normal distribution. No, it is not a normal distribution. It is not a normal distribution. It is a normal distribution. Okay. So if I just ask you whether this is a normal distribution, then what you will say? No. This is false, right? Following is a normal distribution, and this is false. नॉर्मल डिस्ट्रीब्यूशन इज सिमेट्रिक अबाउट द मीन. इट्स नॉट लाइक कि कोई भी कर्व दे देंगे वो नॉर्मल डिस्ट्रीब्यूशन है, ऐसा नहीं है. ठीक है. नॉट ऑल द बेल कर्व्स आर नॉर्मल डिस्ट्रीब्यूशन. ठीक है. Now let's see some interesting fact about this normal distribution. I mean, like these are actually important. That's why I'm telling you. Otherwise, I could have not told you. But yeah, these are actually very, very important facts. I mean, I'm not sure they might ask you in the gate, but in general, it is important. You might have studied this in your 12th class. At that time, you might not be much aware, but let me just reiterate those facts. So this fact says that suppose you find out the area in between mu minus sigma and mu plus sigma. See, the complete area, you know that minus infinity to infinity, this fx, the complete area is 1, right? That's what you know. Now suppose instead of this this fx, if I put whatever is this formula, do you remember the formula? 1 upon 2 pi sigma square root of sigma. I mean, you do not need to remember, but anyway, x minus mu whole square upon 2 sigma square, something like this, right? So suppose you integrate this from minus infinity to infinity, then you are getting it 1. Okay. But instead of that, suppose you integrate this from, let's suppose you integrate this from mu minus sigma to let's suppose mu plus sigma. Okay, if I put the x, I mean, if I integrate, put the x value mu minus sigma, put these limits mu minus sigma, mu plus sigma, you do not need to do it, but I'm just telling you directly. It will be obviously lesser than 1, but the answer is 0.68. Okay, which means if you integrate from mu minus sigma to mu plus sigma, then this area is 0.68. This area is 0.68. Is this okay to everyone? So this area is 0.68, which means, what does this mean? That in this interval, the probability of this interval is basically 68%. मतलब कि 68% people are in this interval only. Okay, this is very important fact. मतलब mean से this is called one standard deviation away. Okay, one standard deviation away. Mean से one standard deviation away, 68% of the population is just one standard deviation away. मतलब average से थोड़ा कम थोड़ा ज्यादा 68% people are there, जो कि average से थोड़े से कम है थोड़े से ज्यादा है. And if you talk about the 2 standard deviations away, which means if you just integrate this from minus mu minus 2 sigma to mu plus 2 sigma, if you calculate this fx, then it is coming out to be 0.95, which means average से अगर आप थोड़ा सा भी दूर जाओगे ना, मतलब most of the people are in this range. 95% people, this is very interesting fact, कि 95% of people are in this range. मतलब एवरेज से थोड़ा सा, मतलब 1 स्टैंडर्ड डेविएशन 68% पीपल, 2 स्टैंडर्ड डेविएशंस 95% पीपल आर इन जस्ट 2 स्टैंडर्ड डेविएशंस. अभी मतलब मोस्ट ऑफ द पीपल आर जस्ट एवरेज. I mean, they are little lesser, which means 2 sigma lesser, 2 sigma greater, I can say, but most of the people are just average. It is very important fact and very interesting also. But if you go little more far, which is mu plus 3 sigma and mu minus 3 sigma, then it is 99.7% people. 99.7% people are just 3 standard deviation away. So if I say that, let's suppose that if I say that our the economy distribution or the wealth distribution is following the normal distribution, then you can say, suppose if I say that our Indian economy is following the normal distribution, then you can say ki Ambani, like you can say Ambani will be here. I mean, Ambani will be here. That's okay. Ambani, Adani, these people will be here. But most of the people are having just average income, And if you ask me, maybe 95% of people, I can say they are having little lesser than average, and some people are little lesser than average, some people are little greater than average. And then if you ask me I mean, that depends on the obviously sigma value. I should not say little. I mean, if sigma could also be larger, but that's okay. I mean, for just sake of example, I'm just saying it little. But if you just go 3 standard deviation away, then almost all the people are in this range. सारे के सारे लोग इसी में आ जाते हैं. Isn't it interesting? ठीक है. Okay, so I think there is no power, and my battery, laptop battery is also low, so I'm not sure if power will come or not. Let's just see if we can continue. Okay. So you understood about the normal distribution, that what is happening. So basically, there is a formula. There is some formula, complicated formula. You do not need to know the complicated formula. There are few things that you do not need to know. Till now, you can say that you have not even you have not even got the flavor that how to solve the questions of normal distribution, because I have not told it. Okay, I'm just telling some facts about the normal distribution, because that is important. Okay. So there is something called standard normal distribution. See, in the normal distribution, your mu and sigma could be anything. Mu could be 5, sigma could be 1, like this, right? Now, in the standard normal distribution, they said that if mu is 0, and sigma is 1, then this kind of normal distribution is basically some special to me, and I will call it standard normal distribution. That is all. Okay. So I will say that there's like generally we denote it by Z. We will say, I mean, generally we denote any random variable by X, Y, like this, right? X, Y, like this. So I will say that this random variable, okay, you can call it X also, but I will say this random variable is denoted by Z. If it is following standard normal distribution, generally I say Z. I mean, you can say X, but that's okay. Okay. I mean, generally we say Z. So basically, a normal distribution which is special, a standard means mu is 0 and sigma is 1. If that is the case and it is a normal distribution, then I will say that it is a standard normal distribution. That is all. Okay. So let's see this question, and then we will come back to the relationship between the standard and normal distribution. Suppose Z is a standard normal random variable, which means, I mean, they should not give you, but I mean, they have just given you, but they need not to give you that mean is 0 or variance is 1. So let Z is a standard normal random variable, then from here you should be able to infer that mean is 0 and variance is 1. So they are saying that Z is having some expectation as 0 and variance of Z is 1. Now find out the mean and variance of this X. If X is some new random variable, can you find out the expectation of X? Where mu and sigma are just some constant. You can say 2, 5, something like this. So expectation of X will be sigma into, since sigma is constant, expectation of Z plus mu, which is, this is 0, so it is mu only. Right? And variance of X will be, yes, Akash. So variance of X will be, this constant will not matter. So sigma square into variance of Z. Since variance of Z is 1, so it is just sigma square. Okay. So that's how you can find out the expectation variance. Not a big deal. I mean, if you remember, I have just given you one example where I said this was 2, 5. I mean, there was one slide. Do you remember? Let me just show you. See. Yeah. So I have given you this example where I said the mean is 0, variance is 1. Okay. And then if X is this, then can you find out the expectation variance? This is the same. Like instead of 5, I'm just saying K1, K2. Okay. I'm just saying K1, K2. Instead of 5, and 2, I'm just saying K1, K2. That is all. That is the only difference I made in that example. So basically, given a X, given a Z, you can find out the X, something like this, right? I mean, if you want to find out the X which is having, so if I say that can you give me an X which is having expectation mu and variance sigma square, then you can say that X will be something like this, sigma Z plus mu. Okay. Now let's see another question where I'm giving you X. I'm saying that there is a random variable X, and which is having mean as K1 or maybe mu and variance as sigma square. Then can you find out the mean and variance of this Z? Can you find out the mean of Z? Can anyone tell me quickly? It will be expectation of X minus mu. Since mu is constant, that's why I'm taking outside. I mean, expectation of mu is just mu, okay, because mu is constant. And upon sigma, expectation of X is given out to mu, so it is 0. Now, similarly, variance of Z will be variance of X upon sigma square, because constant does not matter in the variance. So it will be variance of X is given to be sigma square upon sigma square, it is 1. So now you have the expectation variance. So basically this is important actually, which means if they give you some random variable X, which is having expectation of X something and variance of X something. Let's suppose expectation of X is given to be mu, variance of X is given to be sigma square. And then if they ask you that what is a random variable Z that you can define such that, just tell me a random variable Z such that the expectation of Z is 0 and variance of Z is 1. Then you will say that yes, I can do it easily. You can just define this Z in terms of X. Can you do it? Can anyone tell me what should be the answer? Z equal to X minus mu upon sigma, right? X minus mu upon sigma. Just check it. Just verify it. Let me verify it. Verify the expectation of Z and variance of Z. It should come out to be 0 and 1. So basically, this is the common case that we will be having. Okay, why we will be having? I will tell you. So basically, they will give you that the X, and they will say that convert that to a Z, something like this. That's the only question possible in this normal distribution. Very, very easy, extremely easy. Which means they will give you X, they will ask you can you convert that to a Z? Then you will say, yeah, let me just do it very quickly. That's the only question possible in the normal distribution. Okay, so I hope that is fine. So basically, why we are converting to Z? Let's answer this question. Why we are converting to Z? Which means why we are converting from X to Z, where X is a normal distribution and Z is standard normal distribution. Which means expectation of Z is 0, variance of Z is 1. Here, expectation of X is mu and variance of X is sigma square. Why we are doing it? I mean, why we at all need to convert from X to Z? Let's just answer this. Actually, the answer is very simple. Basically, what happens, let's suppose if you do not convert, okay, and suppose they ask you the probability that X being maybe X being less than 10, then how you will calculate? You will calculate from minus infinity to 10 fx dx, right? And then what you will do, you will put that minus infinity to 10, you will put the formula. Let's suppose the mean and variance are something like this. Let's suppose mean is 3, variance is 4, okay, variance is 4, something like this. Then the formula was, do you remember the formula? 1 upon square root of 2 pi sigma into e power minus x minus mu whole square upon 2 sigma square, something like this, I think, right? So you will put the sigma square is 4, you will put the values of mu and sigma is 2, you will put 2 here, you will put mu here, which is 3, something like this, and then you will calculate. Okay, I mean, for different mu and sigma, the answer will be different, obviously. So this is one way. But what they have done, they have calculated for mu equal to 0 and mu and variance equal to 1, which means they pre-calculated some values. Which means if I say, then they have actually calculated the values which are from minus which are, let's suppose, for any value, let's suppose Z is less than 10, then it will be minus infinity to 10, whatever it is, right? What is the formula? Square root of 2 pi sigma into e power minus x minus mu square 2 sigma square. So actually for Z, it will be fixed. This is fixed is 1. This is fixed to be 0. Okay? For Z, it is fixed. Now what they did, they have calculated these values from any interval to any interval. Okay, they have pre-calculated in one big table. Okay, there is one big table. Okay, in this one big table, they have calculated for every interval, for this Z at least. If you want to find out for minus infinity to 10, you do not need to integrate, because people have done it for you. For Z, people have done. You are getting my point? For Z, there is a table. For Z, there is a table, and if you want to find out what is the Z less than 10, which means from minus infinity to 10, so there will be some value in this table that will tell you minus infinity to 10. If you want to find out Z from, let's suppose, from 5 to 10, they have calculated these integrations already, because mu and sigma were known to everyone. So there is one big table. In this table, that is table only for Z. In this table, they have calculated every possible interval for Z. Now, if they ask you the question about X, then what I will do, instead of calculating these complicated integrals, I will convert this X to Z, and then I will use the table. So basically, why we are doing it? Because I will convert this X to Z, because there is table available for Z. Okay, and we do not need to, and we can directly use the table. Let's just see that how we are going to use. Okay, let's just see some example. Let's suppose that they say that Z is a standard normal derivation, and then let's suppose they give you this. Okay, they will give you about the Z. They will give you about the Z. Actually, they will not give you the whole table. That's not a point. I mean, they will not give you the whole table. They will not ask you to look up the value for the table. They will give you the required entries that is useful for this particular example. So that is coming out from the table. That's okay. So they have given something about the X. They have asked something about the X, and then they have given something about the Z. So what I will do, that X is having mean 10 and variance 4, that I will convert that to Z. Can you convert that to Z? What should be your Z? Z will be X minus mu, which is 10, upon sigma. What is sigma? What is the value of sigma here? 4 or 2? Just 2. So this is your Z. Okay. I mean, first I will convert to Z. Now what they've asked that X is less than equal to 13. So let me just do it. They have asked this value. So what I will do, I will actually use this transformation. I will say that suppose this is your Z. So they want to find out X less than equal to 13. I will say, let's just subtract 10 from left hand side and right hand side. So instead of find out X less than equal to 13, I will find out probability of X less than equal to X minus 10 and 13 minus 10. Okay, which means X minus 10, I will find out this probability. Okay, probability of X minus 10 less than equal to 3. And instead of this probability, I will find out the probability of, I will divide by 2. So I will say this is same as probability of X minus 10 by 2 less than equal to 1.5, right? 1.5, 3 by 2. So basically what I will do, instead of finding out for X, I will subtract by 10, I will divide by 2, and then I will say that this is same as Z. So this is probability of Z. Since this is same as Z, Z less than equal to 1.5. And then they will give you something about the Z. They have given you this, which means this is 1 minus Z greater than 1.5, which is 0.00666. And that's how you can solve this question. So that's the only type of question that are possible in normal distribution. So basically they will give you something about the Z, and then they will ask you something about the X. What do you need to do? You need to convert that X to Z, okay, step by step, and then you can get your answer. Okay, that's the only thing that they will ask. Let's just solve this question. Z is a standard normal random variable, and we know that Z is less than or equal to 2.4. So they've asked this. Okay, so can you convert that to a Z? What is Z? Z is X minus 100 upon variance is 15. Okay, variance is 15, which means it will be square root of, should be variance, or let's suppose this is standard deviation. Okay, I mean for the sake of example, let's suppose this is standard deviation. Okay, let's assume that to be standard deviation, then it means divided by 15. So what you need to do, probability of, first you will subtract 100, right? You will subtract 100 greater than 36, and then what you will do, you will divide by 15. You will divide by 15, then x minus 100 by 15 is greater than 36 by 15, which is I think 2.4. Okay. Now you will say it is z. It is z, which means probability of z greater than 2.4. And then have they given you some hint about this z? Yes. What is that hint? They have said like this. So it will be 1 minus 0.9. That's how you can calculate. That's the only question possible, which means they will give you something about the z. They will ask you x. The whole story is boiling down to these things only. Z is also a normal distributed random variable, but it is just a special, which means the mean and variance are fixed. Let's see this. Okay. So the average height of the certain age group of the people is 53, which means mu average is given to be 53. The standard deviation, which means sigma, is given to be 4. If the variable is normally distributed, find the probability that a selected individual will be less than 57 inch, which means probability of x less than 57. So let's just convert that to a z. Z will be x minus 53 by 4. Okay. So which means it is x minus 53 by 4 less than this will be 1, right? So it will be z, the probability of z less than 1. Let's suppose, okay, they will give you in the question, don't worry. Let's suppose that they give you probability of z less than or equal to 1, 0.8413. Let's suppose they give you this. Then what is the answer? C, right? Yes, C is the answer. Very easy question. Like what you need to do, you just need to convert that to a z and then finally see that what they have given about the z. Okay. Okay. So tell me whether it is true or false. See, if z is standard normal distribution, okay, this is standard. Standard means it is symmetric over the basically. I mean, all the normal distributions are symmetric over the mean, but if it is standard, it will be symmetric over the 0. So they are asking z less than or equal to minus 8. This is minus 8. This is plus 8. Since it is symmetric, so this area and this area is actually same. So this is true. Okay. I mean, you can prove it mathematically also, but let's not do it. I mean, using the graph, we should be able to convince ourselves. So these are the small things that are needed. I mean, they will ask you just this kind of question at max. I don't know like whether they have asked any question till now. Maybe I think they have asked just one question in this normal distribution, but that's okay. Let's just solve this distribution, this question. So x is a normal distributed random variable. I mean, this is mu and sigma. Okay. So mu and sigma square. So basically, mu is given to be 70, let's suppose, and sigma square. I mean, these are the notation. If you're not comfortable, let's not worry about it. I'm just telling you this mu and sigma square. Sigma square is given to be 10 square. A normal random variable, mu and sigma are given. Okay. Find q such that this. You need to find q such that this, which means that p is mod of x minus 70 is greater than or equal to q is equal to 0.32. You need to find this. Can you do it? Do you know x greater than or equal to 5? Mod x greater than or equal to 5, it means what? What are the possible values of x? X could be greater than 5 or x could be less than minus 5 also, right? Less than or equal to greater than or equal to. Because this is mod, if it is less than or equal to minus 5, which means minus 7 or something, then also it is true. So basically, you can say it is greater than or equal to 5 and less than or equal to minus 5. Right? So this probability, just 1 second, it should be the summation of this, right? Probability that this x minus 70 is greater than or equal to 9 plus probability that x minus 70 is less than or equal to minus 9. Minus q, sorry, it is not 9, it is q. Okay. Now let's just convert that to a standard random variable. So standard random variable, if you convert, how it will look like x minus mu upon sigma. X minus 70 upon 10. If you divide by 10 in both the cases, here, then it will look like this. So it is z. So finally, it is coming out to be probability of z greater than or equal to q by 10 plus probability of z less than or equal to minus q by 10. ये समझ में आ रहा है? See, probability of z greater than or equal to q by 10 plus probability of z less than or equal to minus q by 10. ठीक है? which means they have given you something like this. They have given you this. I just opened this up and then I said it is plus, and then I converted that to Z. Now tell me, Z greater than equal to some value and less than equal to some value minus of that value, isn't it same using this observation? Less than equal to minus A and greater than equal to A, isn't it same? Since it is same, I will say that that is given to be, it is 0.32. So it is given to be 0.32. You will say this is 2 into P of Z greater than equal to Q by 10 is equal to 0.32, which means P Z greater than equal to Q by 10 is 0.16. And now let's just see if they have given something. They have given this. If they have given this, then can you tell me this is what greater than equal to? Can you convert that to greater than equal to? Probability of Z greater than equal to 1 will be what? 0.16. I mean 1 minus this, right? So they have given Z greater than equal to 1 is 0.16, and I came out to with this. Then can you just compare what should be the value of Q? If you compare these two, the value of Q will be Q by 10 will be 1, and the value of Q will be Q equal to 10. Okay. See, everything will just boil down to one thing, which is you need to convert X to Z, and you should be able to solve all the questions. This is the, you can say one good question where we are using like this trick also. I mean, this as a trick. Okay. And that's the enough tool that you need to do, or you need to have to solve any gate question, or in future if they ask. Okay. Yeah, Q is 10. Final answer is 10. Okay. Now there are 2-3 questions that I have. Actually, I have some important work at 11 a.m. and I think it is not possible to complete before the 11 a.m. also. So because I need to cover exponential and then we need to cover mean. Okay, it will take just 1 more hour. So I think in half an hour it is not, we cannot finish it. So just can we schedule in evening, just 1 hour in evening, maybe 5 to 6 or something. Or maybe let's just have it tomorrow only. Okay, tomorrow we will have just one session in morning, and we should be able to finish our probability. Okay, just 1 hour is needed, because in evening other people are having classes. I mean, like you must also be having the class, the TOC class, but other people are working and all, so that is why they might not be able to attend. Yes. So let's just continue our discussion, and then we will do it in the next class. Okay. So it is very easy. I mean, they have just asked one question from this probability distribution. If you want, just try this question as a homework. And this is very, very good question. Just try this question as a homework, and you will like this question. They've just asked one question, and that one question itself, they have asked very good question. Okay, try this question as a homework, and we will meet in the next question. So we are just left with exponential distribution, and then okay, as a homework also, don't do for the exponential, at least do for everything else, for Bernoulli binomial quotient and uniform. In case of uniform, both the uniform, just write all these values. Okay, expectation variance, PDF or PMF. As a homework, just fill this table. I mean, you can fill this table using your notes, that's not a problem. I just want to have one table in front of you as a summary. Okay, you should be having a summarized table, that what is the expectation, what is the variance, what is the PDF or PMF. You can just do it as an homework. So just do these two things, which is this, and another one is this. Yeah, Akash is saying probability now seems nice. Actually, to be very honest, probability is tough. Okay, I mean tough in the sense it is not intuitive. Just like linear algebra, probability is not intuitive. Linear algebra is very intuitive, but probability is not intuitive. But anyway, like you might have got much idea about the probability. But after this also, after this mean mode and median, you will get to know, you will get to understand more probably, because here I will be using some intuitive ideas in the probability. Okay. So we will meet in the next class at 7 a.m. only. Okay, Ekta is saying probability revision. Okay, let's just do one thing. Tomorrow in the first session, I just need 1 hour. We will be having the remaining syllabus. And then from like in the remaining 2 hours or 1.5 hours, and the remaining time, maybe 1.5 hours or 2 hours, we will just revise everything. I will not put any new thing, which means I will not put any even a single question. I will not put new. Everything should be the old, so that you are able to connect the dots. Okay, I will put either it is theory or it is question. It will be old question. It will be old theory only. Nothing will be new in this revision. Okay, I think we should be having these kind of revision also, where nothing is new, everything is old, so that you are able to connect the dots, right? So we will be revising in the remaining time. I will give you the good summary about the probability, which means starting from the definition of the probability, then conditional probability, the intuition behind the conditional probability formula, then independence, then the tree method, and then random variable, what is the random variable, and then the type of random variable, discrete, continuous, everything. I will give the complete summary in the tomorrow lecture also. Okay. Take care. Thank you, everyone. Let's meet tomorrow. Take care. Bye bye. Hi, everyone. How are you all? Let's just start. So coming to this normal distribution, can you recall that what was the normal distribution and why we call it normal distribution? I mean, this is just my guess that we are calling it normal distribution is because, can anyone recall me why we are calling it a normal distribution? Because it is so normal. I mean, it is extremely natural in general life. Okay. I mean, any data in the machine learning, we assume that it is following normal distribution. Okay. Reason being is that it is quite often. And also there is one theorem. Obviously, you do not need to know that theorem. That is called central limit theorem. Anyone has heard about CLT, central limit theorem? There is one theorem that is central limit theorem, and it is very interesting theorem about the normal distribution. It says that a mixture of any, some mixture of few random variables, that could be any type, then finally we get the normal distribution. Anyway, there is some central limit theorem which makes this normal distribution mathematically proven that it is actually very common in general. Okay. I mean, as far as I recall this theorem, it says central limit theorem. It is obviously not for GATE, but just for your curiosity, I'm telling you. It says that let's suppose there are different factors in something. Let's suppose you are measuring a fever of a patient. Okay, a doctor is measuring fever of a patient. Then there could be different factors that fever is this because that patient was actually not well, maybe because of that, or maybe there could be some other reasons. Maybe let's suppose that patient was having that kind of hereditary disease, or there could be many different reasons for the fever. And every region, let's suppose, is following some different distribution. But if we accumulate all the different distribution, then finally we get the normal distribution. So there is very nice theorem, central limit theorem. It is quite interesting. I'm not sure if it is interesting or not, but yes, this mathematically proves that that normal distribution is actually very much quite often in the practice. So it is so important and so popular in machine learning that there is no single machine learning algorithm that is like you can assume without the normal distribution. I mean, almost I can say to that extent, it is that much important in machine learning. Anyway, so for our purpose, we do not need much details. We even do not need this formula. There is some complicated PDF formula for the normal distribution, but we do not need it. We just need to know that given any random variable x, how to convert to a standard normal random variable. So let me just recall you that this is how the normal distribution looks like, where you will say that that if the variance is more, let's suppose you talk about this curve, the variance is 4 here, then that is having a more spread. Right? Okay. So there is one very interesting fact. The fact is that if you have any normal distribution, then across the mean, if you just go one standard deviation away, then 68% people are lying just in one standard deviation away. If you go 2 standard deviation away, then 95% people are lying. How I'm calculating these numbers? I have to basically calculate the area of this to calculate like how much is this. See, you know the complete area. How much is the complete area? Can anyone tell me? If you take the complete area, then how much it will be? It will be just 1. Yes, Yuvraj. Yeah. And suppose you take the, instead of the complete area, you go from mu minus sigma to mu plus sigma, then it will come, it is mu minus sigma to mu plus sigma, and then you plug in the PDF, and then you will be getting 0.68. I mean, it will be less than 1 obviously, and it is 0.68. It is interesting. I'm not sure whether it is useful for our gate purpose or not, but I cannot teach random this normal random variable without telling this fact, because it is very important and interesting also. I mean, whenever I hope that you might have studied this normal random variable, this kind of fact before also. Anyone is there who has studied before, maybe in 12th class? I mean, at that time we were not much aware, but we have studied that in 12th class, right? So this is very interesting fact and very, very good fact. I mean, we will be using this. I mean, you might use this fact in machine learning when you study machine learning at the MTech level. Okay. So now, instead of working with the normal distribution, we say that we work with the standard normal distribution. What is a standard normal distribution? Is that, like, we say that a normal distribution is standard if mean is 0 and variance is 1. Okay. Now, can anyone tell me that why it is good to work with the standard normal distribution? Why we are saying that it is good to work with the standard normal distribution? Because, I mean, why we are at all working with the standard normal distribution? Because, see, why we are converting that to, I mean, any random variable x to z, because there is a table available for z, which means, like, you ask me anything for the z, which means if you ask me that what is the integration from 1 to 3, and now if it is the, like, this is basically fx for z, where mu equal to 1, sorry, mu equal to 0, sigma equal to 1. I mean, there is a formula, no? This formula. In this formula, if I put mu equal to 0 and sigma equal to 1, and I integrate from any a to b, okay, it could be anything. It could be minus infinity to 3, it could be 3 to 5, it could be anything. I do have the answer already with me, which means if I integrate this fx for any value, or for any value 1 to 3, if mu 0, sigma is 1, then people have already done it. You do not need to do it again and again. That's why I'm saying that instead of working with x, what we do, we work with z. What is the benefit of working with z? We already know the answers. Okay. I mean, there is a huge table in we do not need that table, but I'm just telling you that there is a huge table, and using that, you can basically just look up for that table and you can get your answer. But for us, they will, instead of giving the table, they will give us the particular value, which means they will give us that z is less than or equal to 2.4. But in the table, you will go for minus infinity entry. You will go for 2.4 entry. You will say, okay, minus infinity to 2.4. I mean, it's not that easy to basically get that entry, because obviously they cannot list out all infinity entries, right? Otherwise, there will be infinity entries. The table is having some nice pattern, some nice compact pattern. That is very nice table. But anyway, like, for simplicity, just assume that there is an entry which is minus infinity to 2.4, and that is already there. Like, I just picked this value from the table only. While I was making this question, I just picked this value from the table only. Okay, so there is a table, and they will not give us the table. They will just give us the particular value. And what we need to do, we need to convert any random variable x to z. How to convert x to z? We already seen it. That a z, which is a standard normal random variable, which means the expectation of z is 0 and variance of z is 1. And how to convert that x to z? We will be just doing x minus mu upon sigma. What is mu and sigma here? These are, can anyone tell me? What is mu? This is expectation of x or expectation of z. This is expectation of, quickly, expectation of x, right? Very easy. So it is expectation of x. Okay. Now there is one very interesting property that is quite handy sometimes and useful many of the times, which says that if you go z less than or equal to minus a, or z greater than or equal to plus a, it is same. I mean, since it is basically symmetric about the 0, so it is either you do this or you do this, it is same. In fact, if you take any random, I mean, any general normal random variable, which means need not to be standard. Let's suppose this is mu. Then also you can figure out. Let's suppose this is mu minus a. Mu minus a. This is mu plus a. Then also you can say that probability of x less than or equal to mu minus a is same as probability of x greater than or equal to mu plus a. Tell me, is this okay to everyone? Is this true or false? If I say for any x, okay, need not to be z. This is true, right? Because it is also symmetric about the mean. See, in the first slide itself, I said that it is symmetric about the mean, symmetric distribution around the mean. Okay, so if you go anywhere from the mean, let's suppose plus a minus a, then these areas are actually same. Okay, in fact, this area is also same. I mean, you can say that from A to, okay, let me ask you the question. Tell me whether this is true or false. Integration of, or maybe instead of saying like this, let me ask you whether this is true or false. X being till mu, and this is, let's suppose, mu minus a to mu is the same as probability of this is mu less than equal to x less than equal to mu plus a. Is this same? True or false? This is true. Reason being is that, see, this is, okay, not this also, maybe this. Okay, so reason being is that this is mu minus a, this is mu plus a, and this area and this area is also same. So anyway, this is symmetric, so from that you can solve these true false questions. Okay, the symmetricity is actually important in solving some of the question. And for example, like we solved this question, and in this question we observed that if you remember this question, let me first recall this question. They said like mod of x minus 70 greater than or equal to 2. Now you know how to solve the question. First you need to convert that to z. So let me just rewrite in this plus form, then we converted to z. Then we realize that, okay, this is z greater than or equal to a and z less than or equal to minus a. Since it is symmetric about the 0, that is why these two probabilities are actually same. And then we said that these two are same, that's why I multiply by 2. So see, this is handy. If you know that this is same as this, then sometimes this is handy in the problems itself. Okay, and then we got the final answer. Anyway, q equal to 10. So now let's solve this question. Has anyone tried this question at home? Anyone? Let x is a random variable following the normal distribution. They are saying normal distribution with mean plus 1 and variance 4. Tell me whether x is a standard normal distribution or not. Is this a standard? No, because mean is 1. Mean is first of all not 0. That's why it is not a standard. Variance is 4. That is okay. And let y be another normal random variable with mean minus 1 and variance is not given to us. And then they are asking variance. I mean, they are asking standard deviation. So first we calculate the variance, then we will calculate in the standard deviation. So let's just solve this question. Do you remember how to solve this normal distribution questions? What we do, we convert everything to z, right? See, we change to z. See here, I mean, like whatever we have, like here we had to solve this, we converted to that to z. I told you that that's the only possibility that you will be having in the gate, that you will be converting things to z. That is the only thing that they will be asking you. I mean, in general also, that is the only way to solve these kind of problems. Okay, so x is given, y is given, but there is no z. So let's just convert things to z. So let's just convert this and this both to z, which means, let me say, x minus what is mu here, 1 upon what is sigma, 4 less than or equal to minus 1, 4. Is this okay? Is this okay to everyone? Is this z? Is this z? This thing? Can I say this thing is z? Or there is some mistake? Yes. Instead of 4, it will be 2. Yes, Ekta. Reason being is that 4 is variance, but we want extended deviation. We divide with the extended deviation. So that's why this is 2. Okay, don't do this mistake. Standard deviation and the variance, don't do this kind of mistake. That is equal to this thing only. And let me also convert that to z so that I can solve the questions. Y minus or plus 1 upon the variance is, let's suppose, unknown, and that is greater than or equal to 2 plus 1 upon sigma. Okay. So on the, let me just copy this. On the left hand side, I got z, which is z less than equal to, here I got probability of z less than equal to, this is z, right? And minus 2 and minus 1. This is minus 1 equal to probability of z. This is also z, where sigma is what? Standard deviation of y. Okay, sigma is standard deviation of y, which is greater than equal to 2 plus 1, matlab 3 upon sigma. This is nice identity. Good one. Sir, in numerator, y minus 1. No, mean is minus 1, no? Mean is minus 1. That's why it will be y plus 1. I hope I'm right. Okay. So upon sigma and 2 plus 1. Okay. So how to solve this? Anyone, any idea? We need to get the sigma. Very easy. This question, I thought this question is tough, but coming out to be very easy. Can anyone solve this question? From here, at least. Identity से कोई कर नहीं सकता क्या इसको? We know this thing. Let me just give you the hint. We know this, right? This true false. See? Yeah, we know this. If z is less, if probability of z less than or equal to minus a, equal to z greater than or equal to a, then basically these two a's are same. Just the sign is different. So let me paste this thing there. Just use this and try to solve it, and just get me sigma. What is the sigma? How much you are getting? Okay, is this so hard to do it? See, this is z less than or equal to minus 1 and z greater than or equal to this, right? So I think, I mean, you can compare that. Okay, this is minus a and this should be a, right? So this is minus a and then this should be a. So which means that 3 upon sigma is a and this is minus a, which means a value is 1, which means sigma is 3, right? So basically you can say if z is less than or equal to minus 1, that is equal to, since it is symmetric over the mean, it means if it is less than or equal to, I mean, z less than or equal to minus 1, this probability, that should be equal to z greater than or equal to plus 1 only, right? That should be equal to z greater than or equal to plus 1 only. So that's why this thing is plus 1. If you even do not directly, like, I actually don't want to just compare with the a and don't want to do like this, because it will not give you the intuitive feeling if you just remember this and then compare with, okay, this is a and what. No, you should not do it. You should do it in the different way, which means you should your approach should be something like this. You should say that, okay, z is less than or equal to minus 1, which means this thing, this probability, this has to be same as, if it is same as z greater than or equal to 1, this has to be same as z greater than or equal to 1, right? You need to drive it again. I mean, you need to drive this kind of identity again. You should not remember these things. I mean, if you remember, that is okay. But to solve this, I think it is better if you do not compare one by one, because it will not give you any feeling. So finally, you will say that 3 upon sigma is actually 1. And then sigma is 3. Was it a tough question? It was a nice question, that I can say. But was it a tough question? No, right? I think it was, it was a very, very good question, no doubt, but it was not a tough question. I mean, if you are good with understanding the things, which means, like, if you know that how to solve the normal distribution question, it's using the Z only. First you convert that to Z, then you just compare, right? Very, very easy. So I think that was approachable. Okay. Now let's understand one more last, I think it is last, yes. So we have seen uniform, normal, and then this is last one, which is exponential. So do anyone remember, by the way, what was the uniform? Uniform, like, we will revise today also, but uniform is basically, it says that the PDF is same. I mean, fx is just c between a to b, something like this, right? Between a to b, which means that this is PDF. This is, let's suppose, fx. It is c from a to b. And to solve this uniform kind of questions, do we need to solve with the integration, or we can directly work with the rectangles? Yes, yes, Ekta, that is right. So we can work with the rectangles directly. Okay, because it is better to directly work with the rectangles. Now let's just see this exponential distribution. Now basically, in the exponential distribution, if any function is following this kind of formula, which means, if any random variable is having this kind of PDF, which is looking like this, lambda into e power minus lambda x, if x is greater than or equal to 0, otherwise if x is less than 0, otherwise it is 0. Now first tell me, what are the parameters in this PDF? Parameters means apart from the x, because x value will be given to me. Parameter is lambda. So you will say exponential. Some people write something like this. Like actually, the notation is like this, that you write the distribution name, which is exponential distribution, and then in the bracket you write the parameters. Which means if I ask you that how do you denote the normal distribution, you will say maybe normal you can write. Otherwise, people just write like this. Then you will say normal distribution. If you want to denote by the normal distribution, mu and sigma are parameters. How to denote maybe uniform distribution? In the uniform distribution, A and B are the parameters. People just like write like this. How to denote maybe position distribution? In the position distribution, lambda is the parameter. So people denote like this. How to denote exponential distribution? People write like this. Maybe x, exp lambda, something like this, right? And what else is remaining? How to denote binomial distribution? Then people write like this. What are the parameters? Anyone remember for the binomial distribution? Binomial was the discrete or continuous? It was a discrete. So in the binomial distribution, we said the parameters are number of trials. It was n c k into p, or then like n c k into p power k into 1 minus p power n minus k, something like this. So in this, tell me what are the unknowns? See, the k should be given, right? Or k is a parameter or should be given? Is a parameter. Sorry, it should be given, right? Because reason being is that k is the value of x. Since k is value of x, it will be given to you. Okay, so k will be given to you, and then n and p are the parameters. So I mean, this is just a general notation like people write in this way. You do not need to actually, I mean, I don't know if you need to know it or not, but yeah, they may write some kind of these notations in the question. But anyway, like you will be habitual of these kind of notations after your MTech. I mean, during the MTech. But yes, this is the kind of notation that the people or the books use. Okay, so if some random variable is having this kind of PDF, then we call that this is said to be exponential random variable. Now, let's just calculate the expectation variance of this exponential random variable. So expectation, like I'm not going to calculate, but how do we calculate? Do you remember any formula? From minus infinity to infinity. So if you do it, then it is going to be 1 upon lambda. Just remember it, okay? So because the doing the calculation is not worthy. Just remember that expectation is 1 upon lambda and variance is 1 upon lambda square. Taken? Is this okay to everyone? Now let's see that what they can ask in the exponential distribution. See, first of all, these continuous distribution and these things, I mean continuous distribution and the whatever in the continuous distribution, which is normal distribution especially, or the exponential distribution, they have not asked any question. I think they have just asked 1 or 2 questions. These are not important as per the gate. I mean, they may ask the question. It is not like they cannot ask the question because it is in the syllabus, but it is just like that. This is less important compared to the discrete random variable. Discrete random variables are very important. Expectation or variance of the discrete random variable or different kind of things that we have studied in the random variable, everything is important, but they just give the less priority to the continuous random variable. Can anyone think that why they are giving the less priority to the continuous random variable? Reason being is that this is basically they do not want to test you on the mathematics much. They want to test you on the logic. Okay, I mean they want to test you on the computer science logics, not on the integration and differentiation, these logics. Even if you go for the calculus, and then in the calculus itself, like they do not ask much tough questions. So they do not ask calculus questions much, right? I mean any hard question they do not generally ask from the calculus. So that is why this continuous also deals with the integration and these things much with the calculus. So that is why they do not ask these questions, and they think that if someone is good in the discrete, and if he is willing to learn, then he can learn the continuous later also after in the MTech. So the GATE exam is just an eligible exam to push you to the top college. So if you're good with some logic, maybe discrete random variable expectation, these things, then they think that okay, you are good to go. It is an exam which tells you that you are good to go, right? So which means if they understand that okay, if you are able to solve the discrete mathematics, the discrete random variable questions, then you are good to go. At least you can understand the continuous later. That's the I think that's the mindset that they are having. I may be wrong, but I think that's the mindset they are having. So anyway, let's just solve some question in the continuous in the exponential random variable. Let's suppose that x is a exponential random variable. And this expectation of x is given to be 0.5, right? And let's suppose that they're asking expectation of some maybe some other random variable that is a function of x, maybe x plus 3 square. Okay, let me just write the expectation of x is 1 upon lambda, I think, right? 1 upon lambda. Can anyone solve this question? See, this will be expectation of x square plus 9 plus 6x, right? Which is expectation of x square plus 9 plus, this is okay, right? Because 9, expectation of 9 is just 9 because it is a constant, expectation of x. Now this is given to us, which is 0.5, that is okay, into 6 plus 9, that is okay. Is this also given? That's the trick here. Is this also given? Just see if this is given. Expectation of x square. Have they given this? See, they have not given the CDF. Obviously, they will not give you the CDF, and they will not ask you to integrate the x square fx and these things. But there is something that you can find out the expectation of x square using the given information. Yes, they have given the expectation, which means they have given the 1 upon lambda, which means they have given the lambda, which means they have given the variance also. Right? Given the expectation, first find out the variance. I mean, first find out the lambda. Lambda is 1 upon 0.5, which is just 2. Lambda is 2. And then they have given the variance, which is 1 upon 4. That you know that expectation of x square minus expectation of x whole square is 1 upon 4. That's what they have given, right? Because they have given the variance. I mean, they have given the lambda. From here, you can calculate the variance. Now, expectation of x square will be, that's what you are interested in to find out. It will be 1 upon 4 plus expectation of x whole square, which means 1 upon 2 whole square, which is again 1 upon 4. That is 1 upon 2. So here they have given this is 1 upon 2. Are you able to do it? 1 upon 2 plus 9 plus 3, that is 9 plus 3 is 12, and then 12.5. Okay? 12.5 is the final answer. Now, the only trick that we needed to apply is this, how to calculate this expectation of x square. And to calculate this expectation of x square, they have given you the expectation of x. Given the expectation of x, you can calculate the expectation of x square. Let's just solve more questions. Let's see that how to solve this question. They are saying that let x and y the independent random variables, both are exponential with lambda equal to 2. Both are exponential random variable, and they're independent also. Now let's just find the expectation variance of u and this w. Expectation of u will be 1 upon 2 into expectation of x plus expectation of y. So I think we can do it. This is 2 plus 2, 4, and then 4 divided by 2, this is 2 only, right? I hope that is easy because this lambda is given to, okay. Is this okay or there is some flaw? I think there is one mistake that I just did. Can anyone tell me? No, that's fine. This lambda is 2, then expectation is 2 or 1 upon 2. Expectation of x is 1 upon 2. Yeah. And expectation of y is also 1 upon 2. Which means it will be 1 upon 2 plus 1 upon 2, 1 upon 2 into 1 upon 2 plus 1 upon 2, which is just 1 upon 2. Right? Okay. Now let's just calculate the variance of u. So variance of u will be variance of this whole thing, which is 1 by 2 x plus y. And then since they're independent, you can separate it out and you can do it from here also. But do we need to do all of this, or we can just do from the lambda? I think we can just do from the lambda. It is easy. So lambda is this, which means, I mean, lambda is 2, and then it will be, I mean, for here also lambda is 2, then it will be 1 upon lambda square, which means 1 upon 4. Okay. We can directly do using the lambda. Otherwise, if you want, since x and y are independent, you can do using this also. Suppose they say x and y are not independent, then dependent. Then can you calculate the variance? Will it be the same or this will be something else? Variance will be same. Okay. However you calculate, the variance will be actually same. because this lambda, once I know the lambda, because see, what is happening here. If it is independent, then basically I have not used a dependent or independent anywhere, right? I mean, let's not use this formula, and I have not used a dependent or independent anywhere. Do I have used, or I'm good with directly solving? I think we can directly solve, because this formula, this expectation of u, does not need any dependence or independence, right? Expectation of u is always equal to linear. I mean, it is linear, so it does not need any dependence or independence. Once I get the lambda, I'm calculating. So this dependent or independent does not matter to me. Okay. Now expectation and variance for this is fine. Now can you calculate the expectation of W? It will be expectation of, this is interesting. Can you do it? Can anyone tell me what is the expectation of W they are getting? Expectation of W is same as expectation of Y square. So expectation of Y is given to be 1 upon lambda, which is given to be 1 by 2. That's why the variance of Y is also given to us, which is 1 by 4. Now, we know this is expectation of Y square minus expectation of Y whole square equal to 1 by 4. That is given to us, which means expectation of Y square, if you want to calculate, this will be 1 by 4 plus expectation of Y whole square, which means 1 by 4. No? This is 1 by 2. Were you people able to solve it? This was 1 by 2. Okay. Now, okay, great. So now let's just find out the variance of W. It will be, I think, 1 upon lambda square. So it will be just, I mean, whole square of this. So it is 1 upon 4. Okay. Okay. So I hope this is fine to everyone. So in the exponential distribution, like this is the only possibility that they can ask. They can just trick you in this expectation of x square and expectation of x. I mean, they will just give you expectation of x. They may ask something which is related to expectation of x square. Okay. And how to calculate the expectation of x square using the variance. So this is just a formula, and you do not even need to remember the formula. I'm again saying you do not need to remember the formula for the normal distribution, neither for the exponential distribution. I mean, if you do it, it might be beneficial because no one knows that what they can ask. But I don't think that you need to remember the formulas. Okay, you just need to remember these things: expectation and variance. You need to remember this for sure. Okay. Now, can you fill this as an homework? Which means just write the one only. Okay, see, these are the parameters that they have written. Okay, in the uniform, just do one thing. In the uniform, there is also discrete uniform and continuous uniform. So the parameters in the both the uniform, I think A and B, right? In both the uniform random variable, the parameters are A and B, I think. So you can just adjust this uniform maybe after this position. Let me do it. Because this is the discrete, no? So that is why just adjust this after this position. Okay. And then this is discrete. Then what we say, that what is the PMF for this? We say, I think 1 upon B minus A, or B minus A plus 1. How many numbers are there? B minus A plus 1 numbers are there, right? So I think it is 1 upon B minus A plus 1. And every number is having equal probability. So I think it is 1 upon B minus A plus 1. And we just write all of this PMF and PDF. I think this is a good table that we can fill so that everything is in front of us. And just one last thing that you can do, maybe just add one more column where you just write the possible values of K, which means here in the Bernoulli, I think K, which means the value that X can take, I think only 0, 1. Here it can take, do anyone remember? In the binomial, it can take from 0 to n. In the position, how much it can take? Can anyone remember? It can take from, since it is discrete, it cannot take the continuous value. It can take from 0, 1 to 3 to n. Is this correct in the position? No, right? It is basically anything till infinity. What about the uniform? In the uniform, I think it can take from A to B, right? A plus 1, like this. In the normal distribution, what are the possible values that X can take? I think X can take any value, right? Yeah, minus infinity to plus infinity. X can take any value. And in the exponential also, exponential actually, X cannot take any value. I mean, if X is less than 0, then it is defined to be 0. Okay. I mean, any value, which means like if X is greater than or equal to 0, then only it is positive. So if you want, you can just write like this. Okay. That if X is greater than 0, then it is positive. I mean, just write the values where X can take the non-zero values. Okay. Can take non-zero values. Can be non-zero. It can be non-zero only at X greater than or equal to 0. And in this case, that X can take any value from A to B. From A to B. Okay. Just write the X values also. Now with this, we are glad to announce that we have actually covered just one part of it. Now we will be needing 8 or 9 more lectures to cover another part, which is statics. So we have covered one part, which is random variable, uniform. I mean, in the random variable, we have uniform. Uniform is continuous and discrete both. Continuous and discrete both. Okay. And normal, which is continuous. Exponential is continuous. This is discrete. This is discrete. So we have covered just probabilities. And this standard deviation conditional probability based theorem, we have covered it. Now the another part, which is statics. Statics means mean, mode, median. These comes under statics part. So yes, we do not need obviously 9 lectures. Obviously, it was not a good joke, I know, but we just need I think 15 or 20 minutes to cover this statics part, which is mean, mode, median. Let's just see this. Okay, what is mean, mode, median? I'm not sure if they have asked any question in this, because this is recently added portion. I think they have added it just 2 years back. So if I'm able to recall, then they have just added in 2021. Just 2 years back, they have added this mean, mode, median part, I think, or maybe 2020. Not lesser than 2 to 3 years. At max, it is 2020, not lesser than 2020. They have added this very recently. So let's just see what is mean, mode, median. Do you remember the numbers that we have talked about? One was the expectation, another is variance. I think these are the 2 numbers we have talked about, right? Expectation and variance. This mean is same as expectation. I mean, the average number. Mode is basically the most frequent number that you can have. Median is the middle number. Let's just see that how to calculate these numbers. Before I go to calculate these numbers, tell me, can you calculate the expectation? Can you calculate the variance? How to calculate the expectation? I think you know, which is basically using the formula, which is, I mean, depends on the random variable, whether it is discrete or continuous. But for now, let's just see that this is the discrete random variable. And for the variance, I think you can do it, right? Expectation of x square minus expectation, or maybe let me write another formula. What was that formula? Expectation of x minus expectation of x. Do you remember there were 2 formulas? And this formula is actually the main formula. And then we simplified that to another formula, which was coming out to be expectation of x square minus expectation of x whole square. Okay. So you can calculate this expectation and variance. Now, suppose instead of giving you probabilities, if I give you the data, okay, it is basically after the probabilities. If I give you the probability, given probabilities. Suppose if data is given to you, given data, then can you calculate the expectation? I think we can calculate. How? We can just take the average. Okay. So if data is given to you, then we cannot do anything. We can just take the average. And do average consider the probabilities? Yes, basically from the average, you are actually finding out the probability, and then you are finding out the expectation. So it is just an average. Maybe x1 plus x2 plus x3 plus xn upon n. I mean, given the data, you can find out the average, and this is just expectation. Okay. Now, given the data, can you find out the variance? If probabilities and these things are not given, then maybe you can say that x minus this average that you have, whatever average you have, and this whole square. Okay, so this is x1 plus similarly x2, whatever the second point you have, x2 minus average whole square, right? Average whole square like this. Okay, let me do it clearly. So given the data, also we can calculate these numbers, and given the probability distributions, also we can calculate these numbers. So these numbers are basically looking like this: xi minus average whole square, and since this is average, so again summation. Right? Everyone is comfortable with these 4 things. I mean, given the data, given the probability distribution, how to calculate these 2 numbers: expectation, variance. Okay, I think this is easy. Like, you just need to take the average, and subtract. I mean, take the distance from the for the every point from the mean, and then take the square, and then take the average out of all. Okay. Now let's just see that how to calculate these numbers, which are mean, mode, median. I think mean is just an expectation, that is okay. So let's just see how to calculate this mode and median. Now, again, first we are going to see that how to calculate this mode and median using the data. I mean, if data is given to us, and then we will see how to calculate this mode and median using the probability distribution. Let's just see using the data. So mode is one number, again, to remind you, which is the most frequent number in the data. And median is the middle number. Let's just see that what does this mean. If I say you that find the median of this data, median means middle number. First you sort this, which is 0, 1, 2, 4, 5, and then tell me the middle number, which is 2. So you will say median is 2. So given the data, it is very easy, right? Median is 2. Now, median of this data, you will just sort it, maybe 10, 20, 40, 50, and then you will say that, okay, if in between, if there are two numbers, then you will just take the average of these two numbers. 20 plus 40 by 2, it is 60 by 2, 30. Okay, median is 30. Okay. Now, given the data, I think it is very easy. You just sort it out and then take the middle value. If in the middle there are two values, just take the average. Okay. Let's just find out the mode of this data. Mode is the most frequent number that is coming out to be. Then what do you think? What is the mode of this data? This is coming out 3 times. This is coming out 4 times. This is coming out 4 times. This is coming out 1 time. Then what is the mode of this number? This is 1, 2, 3, 4. Yes, that is correct. Mode is basically 1 into both, because 1 and 2 both are coming out to be equal number of times. So you will say mode of this number, this data is 1 and 2. Okay. Whatever is coming out to be most frequent time, this is mode. If there are multiple numbers, you will say there are multiple modes. So given the data, I hope you can calculate this mode and median. Okay. Mean is just an expectation that we already know. You remember the difference between the expectation and the average? What is the difference? Actually, there is no difference if the data is huge. So expectation is also an average, right? And like we need to add just one more line. I mean, saying that expectation is an average is not 100% correct. Expectation is an average. It's not 100% correct. Like we can just add one more line to make it more correct. What we can add? Just two more words. What are those two more words? Expectation and average on large data. Yes, on large run or large data, whatever. I mean, whenever they say expectation, just treat it as in just an average. If the data is huge, then both are same. Okay. Okay, Yuvraj is saying these are the 3 numbers. Actually, it's on. Okay. If you want to call this as a word, these are the 3 words. You want to call this a word, so that's okay. I was just thinking about the large run. Okay. So anyway, I hope that you know that what is like how to calculate this mean. But now we are going to see that how to calculate the mode and median using let's suppose they give you the probability distribution. Suppose they give you some probability distribution, then you know that how to calculate this mean. At least the mean is clear to everyone, which is this one. Just 1 second. Right? So mean is clear to everyone, which is this one, which means to calculate the mean, I will calculate the expectation. If it is discrete, then I will do like this. If it is continuous, then I will do like this. Okay. Now, suppose we want to calculate the median. If we want to calculate the median, then what we will be doing, given the probability distribution, it is actually very tricky. It says that mx is defined to be median if the probability of x, like probability of random variable x is less than or equal to mx is greater than or equal to 1 by 2. Okay, and the probability of x greater than or equal to mx is greater than or equal to 1 by 2 for discrete random variable. What does this mean? Let's just try to understand this. So suppose mx is some value which is satisfying this thing. Then we call, if mx satisfies this thing, given the probability distribution, given probability distribution, if mx satisfies this property, then we call it median. And what does this property says? See, it is saying that mx is being less than equal to 1 by 2. Sorry, this x is being less than equal to mx. This probability is greater than equal to 1 by 2. What does this mean? It means that random variable is basically, let's suppose that these are the different values that you have. Now, let's suppose that this is mx. This is mx. Now, the values of x that x can take less than equal to mx, which means in this area, the values that that the random variable x can take, including this mx, is the half probability, or maybe greater than a half probability, greater than equal to half probability, which means half of the points must be in this. See what I'm trying to do here. Let's suppose that I am given a probability distribution and I try to draw a sample. Okay, if I draw the samples, then the samples should follow this kind of thing, which means wherever this mx I have drawn, and then if I draw many samples, then half of the samples should be from this area, and half of the samples should be from this area, which means that the probability that x will be here is greater than or equal to 1 by 2. The probability that x is here is also greater than or equal to 1 by 2. How can both the probabilities be greater than or equal to 1 by 2? Okay, the thing is that this median could be spread over multiple points. I mean, there could be multiple medians. I mean, the data, I will just tell you, not multiple medians. Basically, there are multiple points which are having the same value as median. So let's just understand with the example. Okay, and then we will probably come back to this definition again. So let's first understand with the example, and let's just take this example. Suppose that they have given you this this random variable x, then they are saying a discrete random variable x can take on the values which are 2, 3, 4, 5, 6. And this is the probability distribution that they have given. Now what they are saying, construct the probability distribution table for x, find the mode, find the median. I mean, they are saying first, this means just write the PMF and find out the mode and find out the median. Let's just do it. Okay. So, and then you will get to understand what I'm trying to explain you. So suppose that this is given to you. Let's just maybe find out the PMF. I mean, now let's just write down the PMF. So for the different values of x can take different values, which are 2, 3, 4, 5, and 6. And then this probability distribution is saying that x being 2 is 4 upon 90 probability. This being 3 is 9 upon 90 probability. This is 16 upon 90 probability. This is 25 upon 90 probability. This is 36 upon 90 probability. Okay? And I mean, this is the probability distribution that you have. Okay, let's just find out the mean and mode. Sorry, not mean. I mean, mean you can find out. That's not a problem. But let's just find out the mode and median using this probability distribution that they have given to us. So using the data, are you comfortable using the data? How to find out the mean and mode, mean, mode, median, anything? Using the data, I think you are comfortable, right? Now let's just do it using the probability distribution. How to find out? The thing is that we are not going to apply any of this formula. I mean, there are formulas to apply. I mean, if you want to find out the mean, then median, then this is the formula. If you want to find out the mode, then there is a formula that is saying that probability of x mode is an overall maximum, something like that. Okay, but we are not going to use those formulas. I can verify using those formulas, but we are not going to use those formulas to get the answer. But once we get the answer, we can verify the answer using the formulas. Let's just do it in that way. We will find out the answers without using those formulas, but just for our satisfaction, once we get the answer, we can verify whether the formulas are working on the given answer or not. Okay, let's just do it in that way. So what we are going to do, given this probability distribution, can you just draw the samples from this probability distribution? Let's just try to draw the samples. Suppose you draw maybe 90 samples you draw. Okay, which means that there will be 2, there will be some 4, some 3s, there will be some 4, there will be some 5, there will be some 6. Right? If you draw the 90 samples, let's suppose that this 2 is coming maybe 10 times out of 90. How many is remaining? 80 is remaining. Maybe let's suppose 3 is coming maybe just out of 80. Maybe let's suppose it is coming let's suppose 30 times. Then how many remaining? 30 plus 10, 40. 50 is remaining, right? Then let's suppose this is coming 20 times, then 30 is remaining. Let's suppose this is 10, this is 20. Okay. Suppose, which means if I draw some data for using some samples from this probability distribution, suppose this is what I'm getting, which means 2 is appearing 10 times, 3 is appearing 30 times, 4 is appearing 20 times, 5 is appearing 10 times, and 6 is appearing 20 times. Let me know if this is okay to everyone. Is this, first of all, is this possible to get this data from this probability distribution? Yes, this is very much possible. But actually, this is not a good sample that justifies the probability distribution, which means if I just hide you for a moment, I just hide you this information from you, okay? And I just give you the data. And I ask you the question that what could have been the probability distribution? Then what you will say? You will say the probability distribution could have been, I mean, if I just hide you this particular thing, just one second. Let me go to the next page so that it is okay. Okay. So suppose that if I just hide you this particular thing for a moment, and I do not tell you the underlying probability distribution, I just give you these samples. I just ask you that what could have been the probability distribution that led to this particular data. Then you will say the most probably that X being 2, the probability is 10 upon 90, right? X being 3 is the probability, the 30 upon 90. I mean, what I'm doing, these are not real probabilities. These are sample probabilities, basically. I mean, given the some small sample, I'm just finding out the probability. If I give you the huge sample, then probably you can get closer to the real probabilities. These are the real probabilities, right? These are the real probabilities. And I mean, people call it population probability, real probability, something like that. But these are called sample probabilities. Okay, these are sample probabilities. And given this sample, if I just ask you that what could have been the real probabilities, you might approximate like this. There is no magical power that you can get these real probabilities. But from this data, you can say that most probably this could have been the probabilities. That the probability of X being 4 is 20 upon 90. Probability of X being 5 is 10 upon 90, like this, right? You can easily get the probabilities from the data. But is this real probability? I think 4 upon 90, this is just 1 upon 10 upon 90, this is 30 upon 90. This is not a good match, right? I mean, this is okay that you can get this kind of probabilities, this kind of data. First of all, let's suppose that I do not know the underlying probability distribution. So you can get the samples, this kind of sample, that is okay. But from this kind of sample, if you find out the probabilities, then this will be not the same probabilities. That is okay. I mean, this was just some 90 samples. Maybe in the 90 samples, it is not justifiable. Let's suppose if I draw maybe 10,000 samples, then probably I will get closer to the real probabilities, right? Maybe if not 10,000, maybe 1 million. If not 1 million, then maybe 1 billion, right? 1 trillion, which means like if I have a good amount of data, then probably these sample probabilities will approach to my real probabilities. But let's not worry about it. I mean to say that yes, this kind of samples are possible, but the problem with this sample is that it is not a good justification of my probabilities, right? Actually, what I want to do, I want to forget about the probabilities, which means given these probabilities, I just want to forget about the probabilities. I want to work with the samples. So let's have a sample which is the very good justification of my probability, because I'm just doing a jugaad. Okay, this is a pure jugaad, which means I was expected to work with the probabilities, to be very honest, but I am not much comfortable to work with these formulas. Okay, so these formulas, let's suppose I'm not much comfortable to work with, so I'm just doing a jugaad. What is the jugaad? I'm just drawing the samples. ठीक है, अगर जुगाड़ लगा ही रहे हैं तो थोड़ा अच्छे से लगाते हैं, which means let's have some numbers which is better justification of my probabilities, so that I can forget about these probabilities and I can say, okay, these are my sample points. ठीक है, so I will fake my samples in a perfect way. I mean, एकदम ideal samples लेते हैं. ठीक है, 90 samples, we will draw the 90 samples and we will say that this is the 90 samples we are getting. So now can you tell me what could have been the perfect jugaad? See, instead of this, let's just have the perfect jugaad, which means I want to forget about the probabilities. So that's why I want to have some good numbers here. Maybe if I'm drawing the 90 times, you can say it is 4, it is 9, it is 16, it is 25, it is 36, which means 2 is coming 4 times, 3 is coming 9 times, 4 is coming 16 times, 5 is coming 25 times, and 6 is coming 36 times. Okay, this is actually the perfect jugaad. You can say it is a perfect one. So now I will forget about these probabilities. I will say that let me work with the data, because this data I have just faked it so perfectly that it looks like the real probabilities. I mean, these are the actually real probabilities. So let's just work with this data. Is everyone okay till this point? See, I was expected to work with the probabilities, but I will not do that much calculation. I will work with the normal data. ठीक है? तो पहले एक बार data sample कर लेते हैं और data perfect data sample करेंगे. Now let's just find out the median, which means if 2 is coming 4 times, 2, 2, 2, 2. Now 3 is coming 9 times, 3, 3, 3, 3, 4, 5, 6, 7, 8, 9. Okay, 4 is coming 16 times like this. So can you tell me the middle point? Can anyone tell me the middle point? Such that the half of the numbers are here and half of the numbers are here. I think, see, this is 9 plus 4, 13. And 13 cannot be the, 4 cannot be the middle point, I think. This is 13 plus 16 is 29. Sorry, 13 plus 16 is, yeah, 29. So till this point, now here there are many 5s. Before this 5, there are 29 points. And let's suppose after this 5, there are 36 points. नहीं, ये तो इतना अच्छा नहीं है 5. ये वाला 5 अच्छा नहीं है क्योंकि before this 5, there are 29. And I think some middle 5 maybe, right? Maybe you can say that this is 36 and how many? This is 25, right? तो कौन सा वाला 5 लेना चाहिए? Maybe you can have a 5. ठीक है, कोई फर्क नहीं पड़ता, मतलब बेसिकली इस बीच में से एक 5 होगा. Is everyone agreeing with me that one of the 5 will be there? Maybe this one, right? Maybe this one, because 6 cannot be the median, because 6 से पहले there are like this is 36 numbers and these are more than 36 numbers. So this is one of the 5, 16 5. Okay, so 16 5 will be there. Okay, it's not a great mathematics to calculate that which one 5 will be there. So you can say the median is 5. How we have calculated? Using the data. We will not do using the probability distributions. Okay. Now let's just see if it is matching with my formula. What was the formula? I mean, just to be, make sure that it is actually correct. You do not need to cross check in the examination, but just for sake of doing it, let me just do it. Basically, the formula says that probability that x, the x being less than this median is greater than or equal to 1 by 2, and probability that x being greater than median is also greater than or equal to 1 by 2. Let's just see if this is true. Probability of x being less than 5. Let's just check this. Probability of x being greater than 5. Right? So let me just show you the formula. Sorry, this is x less than or equal to, yeah. Sorry, this 5 should be included. This x less than or equal to here and then greater than or equal to here. Can you calculate these probabilities? I think we can easily calculate. This is what we know, and then we want to calculate these probabilities. Let's just calculate it. X less than or equal to 5 matlab you will add all of these numbers. Just add all of these numbers. This is 4 plus 9 plus 16 plus 25 upon 90. And x greater than or equal to 5 matlab you will add all of these numbers, 25 plus 36 upon 90. Let's just check whether both of the numbers are greater than or equal to 1 by 2 or not. I hope you can easily check. This is 25 plus this is 9 plus 16 is again 25, and then 50, and this is 54, which is greater than 45. Basically, this number is greater than or equal to 1 by 2, right? You can easily check. This number is greater than or equal to 1 by 2. So that's why this number is greater than or equal to 1 by 2. Okay. And similarly, this is 61 upon 90. So that is why this is also greater than or equal to 1 by 2. That's why this is greater than or equal to 1 by 2. I mean, you can verify, but we do not need to verify. Okay. So what we will do, we will just fake the data. We will get the samples, the perfect sample that we can get, and then we will calculate the median. Okay. So that's how we will be solving the question. Instead of solving the question using this formula, it will be tricky actually. If you solve the questions using the formula directly, you might get confused. So the perfect way to do is like this. Now let's just find out the mod. Now can you find out the mod? Given this perfect data, can you find out the mod which is coming most number of times? Can you tell me which is the number which is having the most number of times? Obviously it is 6, right? So you can say, let me write here only, mod is 6. Let's just see with the formula. Actually, formula is very easy for the mod. It is only the median which is tricky. Mod is saying that for the mod, they are saying that mod is any point for which probability of being that point is maximum. So you from this PMF only you can say mod is 6, right? Because they are saying the probability of being that mod is overall maximum. Okay. And in case of continuous, instead of PMF, it will be CDF. So anyway, like that's all we need to know for this mean, mode, median. Mean, you know how to calculate mean, and then mod is just a most frequent number, and what was the other number? Median. Yeah, median is just a middle number. Given the data, we can do it. Given the probability distribution, we will just fake it and then we will do it. Okay. I hope that is easy. Now, maybe for the continuous case, if they ask you to find out the median, actually they will not do it. But can we draw the samples? I don't think it is easy to draw the samples in case of continuous. But it is easy. For the formula is actually easy. For the continuous, the formula itself is easy. Right? They are saying it is just one number for which the CDF, this is CDF, right? Do you remember the CDF? There was a PDF. There were three terms: PDF, PMF, and one is CDF. Tell me, PDF is for continuous or discrete? It is for continuous. PMF is for continuous or discrete? It is for discrete. CDF is for continuous or discrete? Yes, it is for both continuous and discrete. Okay. So this formula is actually easy. If they ask you the median for the continuous case, then it is you can find out the median like this. What does this say? Let's just try to understand this intuitively. What does this formula says? Maybe let me copy it to the next page. So this is median, and I hope median for the discrete is okay to everyone. Let's just see that what does this median for the continuous, what does this say? It says the probability, if you, let's suppose there is some CDF, okay, I mean CDF could be anything, sorry, not CDF, PDF. Let's suppose there is some PDF of the continuous, it could be normal distribution or some other distribution. What they're saying that median is some point for which you will say that, let's suppose this, if I call this is median, then you will say that there are half number of points. X is less than or equal to median. There are half number of points. I mean, if you draw the samples, there are half number of points which will be coming less than or equal to this particular data. Okay, this particular median. So which means in case of normal distribution, can you tell me the median? See, this is actually very symmetric about the mean. So if mean is mu, in case of normal distribution, median is also mu. In fact, for the normal distribution, mean mod, because this is highest, right? Do you remember the definition of mod? This PDF should be highest. Since at the mu, the PDF is highest, so that's why it is mod. And this is also the median. Median means that it is at middle. I mean, there are half number of people that are lying here. Okay. If you calculate the area of this, the whole area is one, but this area is 1/2. And this area is also 1/2. So it is satisfying this property. Actually, all are same for the normal distribution. Okay. Anyway, like you do not need to know these things to that much extent. If you can, like at max, they will ask you using the discrete values, then you can just draw the samples. You can do it. If they ask you, even if they ask you using the continuous values, then in the continuous, actually it is easy. It's not tough. It's just saying that the CDF, which is fx, and then if you put the median here, then it should be 1/2. Okay. Now let's solve one question. Here, this question has been asked in GATE 2017. They are saying that X is a Gaussian random variable. Okay, Gaussian and normal both are same actually. Okay, Gaussian is just one more popular name. Gaussian random variable with mean 0 and variance sigma square. Okay, mean is 0. X is something like this, where mean is 0, and there is some variance which is sigma square. Okay. Y is another random variable which is taking the max of X, 0. Where max of a, B is maximum of a, B. They are asking median of y. So this is X. Can you draw y? Y will be maximum of 0, X. So if you take maximum of these values, then it will be just 0. I mean, these value these are the negative value, right? -5 or something. If you take a maximum of any, I mean, X could be anything from -infinity to +infinity. X could be anything, including the 0 like this, right? X could be anything. But if you take these values from the X, and then if you take the maximum with the 0, then it will be 0 only. So basically, y cannot be negative. Because if x is negative, then y is not negative. You're getting my point? See, if x is negative, x could be anything from minus infinity to 0. For all of these values, by just 0. Just 0. And if x is positive, which means maybe greater than 0 or 0 to infinity, then what is y? Y just x, which means y PDF will look like this. Anyway, like it cannot take these values, so it will look like this. That it is 0, it cannot take the negative values, and this PDF is same. This PDF is same as this. Basically, y PDF will look like this. Right? Okay. Now, what they're asking is median of y. I think it is easy. See, can you tell me the median of x at least? It is 0, right? 0. Now, what I did, I just compacted half of these values. See, the half of these values in just one value 0. In just one value 0. Which means I just compacted all of these values in just one value 0. Now, which means that that for every x, see, let me just write like this, that x may take any values from minus infinity to maybe 0 to infinity. With what probability that x is taking these many values? Probability that x is less than or equal to 0. Can anyone tell me? And probability of x greater than or equal to 0. This is 1 by 2. This is also 1 by 2, right? Now, whenever x is less than or equal to 0, can you tell me what is y? Probability of y being 0, isn't it same as probability of x less than or equal to 0? Because whenever x less than or equal to 0, y is actually 0. That means it is also 1 by 2. Right? Now, tell me what is the probability that maybe you can write y less than or equal to 0. Also, it is fine, right? I mean, actually, y cannot be 0. That's why it is. I can write y less than or equal to 0. I mean, just for the sake of writing, I'm writing it. Okay. So y less than or equal to 0, because y cannot be actually less than 0. Because if I say y less than or equal to 0, it means that y equal to 0, right? For the sake of writing, I'm writing it. Now tell me what is the probability that y greater than or equal to 0? When can y greater than or equal to 0? Whenever x is greater than or equal to 0, isn't it? I mean, whenever x is greater than or equal to 0, y is already greater than or equal to 0. And then what is this? This is 1 by 2. So probability of y less than or equal to 0 is also 1 by 2. Probability of y greater than or equal to 0 is also 1 by 2. Probability of y less than or equal to 0 is 1 by 2. Probability of y greater than or equal to 0 is also 1 by 2. Isn't it satisfying the median formula, which means probability of y greater than or equal to that median, whatever is this median, it should be greater than or equal to 1 by 2. Probability of y less than or equal to whatever is the median should be greater than or equal to 1 by 2. Isn't it saying that median is 0? Because is it saying greater than or equal to 1 by 2? It is, you are getting 1 by 2, that is fine, right? So you can say median is 0. How you are saying it? Because there are half of the numbers which will be less than or equal to 0 for the y, or in fact, like half of the y will be just 0. Okay. I mean, the half, if you draw the sample, like you will be getting many zeros. You will be getting many zeros, and you will be getting half of the numbers greater than 0 actually. So from this, you can say, even from the formula, you can say that half of the numbers like you are getting that are basically are less than or equal to 0, and half of the numbers are greater than or equal to 0. And the formula says that there should be the probability which is greater than or equal to half, which means there are many points like x lie in this area is the greater than or equal to half probability. See, let's just understand like this. See, probability for the median definition, I'm saying greater than or equal to mx is greater than or equal to half. What does this mean? It means there is a median is such a point such that x being in this area, half of the points should be in this area, right? So let's just for the sake of explanation, I will modify it for the sake of explanation. Let's just write like this, equal to 1 by 2. So they are saying half of the points should be here. Is this okay to everyone? That x greater than or equal to mx and x less than or equal to mx, which means mx is such a point, or median, let me just say median m. M is such a point where the probability that any number greater than equal to one, there are half numbers here and there are half numbers here, which means if you draw the samples from this kind of probability distribution, you will be getting half numbers here, you will be getting half numbers here. But the problem with this exact equal to is that, can anyone guess the problem with the exact equal to? Is that basically median are multiple. Medians itself could be in this area, right? Median itself could be in this area. Median itself could be in this area. That's the problem. Which means, like, I do not want to go to much detail, but if you're just writing median M, then someone will argue that, see, your M is this, and the M, like if you talk about M less than equal to M, then there are not just exact equal to 1/2. It is actually greater than equal to 1/2. Someone will argue something like this. I mean, basically, there could be multiple medians. If this is just one median, then I think it should be just 1/2. But if there are multiple medians, which means that the median, there could be multiple medians which are possible, then it will be greater than equal to 1/2. And this will also be greater than equal to 1/2. So you can say that more than half of the numbers are here and more than half of the numbers are here. If more than half of the numbers and more than half of the numbers are here, then is this possible that if there are 100 numbers, then is this possible that 60 numbers are here, 60 numbers are here? Obviously not possible. Some of the numbers are common. And what are those numbers? Those are actually medians, which are common. Anyway, like, you do not need that much explanation. That's why I'm keeping myself to very restricted. You just need to know, for this particular question, you just need to solve this question using the formula, which is basically like this, that by less than equal to 0 and by greater than equal to 0 should be greater than equal to 1/2. I mean, by less than equal to median and by greater than equal to median, both should be greater than equal to 1/2. And in fact, for 0, it is true. How we have calculated it? Using our intuitive idea that y less than equal to 0, which means if I want to calculate y less than equal to 0, you will say it is same as y equal to 0, and y will be 0 whenever x is less than equal to 0. And which is 1/2 because it is a symmetric distribution. I mean, it is a normal distribution about the 0. So, and y greater than equal to 0, it is possible only when x greater than equal to 0. This is also 1/2. That is why 0 is median. Okay. Okay. So we have covered about all of these numbers, which are mean, mode, median, and these are the formal definition. But we generally do not need formal definitions. We will just draw the samples. Okay. So they have not asked any question till now. I think from this, I think they have just asked this question, and even at that time, it was not even mentioned that it is like mean, mode, and median in the syllabus. At that time, they've asked. In 2017, it was not mentioned that it is in the syllabus. I think in 2020 only they have added. If I'm correct, I think I'm right. Okay.